In this week, we're going to talk about Houdini terrain tools and learn how to use them to create various displacement maps that we can use to add details to our rock. We're going to be also creating various rock formation, 2D rock formation, using a variety of techniques and SOPs. We're going to be looking and using the terrain tools in a very different way. Rather than just making terrains, we're actually not going to be using it to make terrains at all. And hopefully you guys will learn some new ideas and new techniques on how you can create geometry that you can use to as assets in the environment or to add procedural details to your existing geometry. Thank you so much for watching, and let's get started. Thanks. So now we're going to start looking at the Houdini terrain tools and what it is made of in reality. And I want to talk about the data available in Houdini in general. And the first thing we have is geo. We have geo by default, and then we have volume. And these two are the two types of all the data that exist in Houdini. It's either geo or volume. And inside of the volume, we have a type of volumes called VDB, and another type which is the Houdini native volume called Houdini volume, so we'll call that vol. And there is not so much difference in terms of these two, it's just this guy is much more memory efficient and much faster. Now with the geo, we have points, so PTS, we have prims, and then anything that is made of these guys is considered geo, so particles, splines, curve, anything like that is part of geo. And then with anything with volume is part of the volume section in Houdini. Now the terrain tools is actually made of volume, which is the native Houdini volume, but it's not a 3D volume. So if we have in the case of a 3D volume, we'd have a domain, and inside this domain there is what we call voxels. So this domain is split into small cubes that are known as voxels. And the more voxels you have, the more details you're going to get in your volume representation. And this is defined by a size, or defined by the size. The smaller the voxel is, the more details you get in the domain. And the higher the resolution, the slower it's going to be. Now the terrain tool, Side Effects, did something very, very unique in this approach. They added something new to the volume. They are using a 2D volume, so it's just a 2D domain. It doesn't have height. It has only voxels along the X and Y axis, along the X and Z axis. And there is no height. It doesn't go up at all. But they added something to allow displacing the voxels up without having to make it a 3D volume. So now you can take a 2D volume and displace the voxels up and down, and you can see them in the viewport displayed as geometry, not just as a volume, as a transparent volume, but you see them as actual points, and you can shade them properly. And this approach is much, much faster than any other approach for doing displacement or height field generation. And everything that we're going to be doing in using the terrain tools is applicable to geometry. There's nothing specific about the height field that we cannot do to the points. The only thing is combining volumes and mixing different density fields or different height fields is much, much nicer with volumes, because you can blend, you can have nice transition between different materials and different bumps and things like that. With points, it's much harder to do that kind of stuff. And in order for us to get a lot of details, we need to increase the points. If we were to do this on a grid, we need to increase the point really high to get enough details, which is not necessarily needed with a volume display. So let's take a look and see this in action. So I'm gonna create a grid, okay, and I'm going to create a point VOP, and let's set this grid to 1000 by 1000, and let's give it to 150 to 150 points. Okay, so now we have that, and I'm going to dive inside and create a noise. Okay, and this noise, I'm going to change the height only. I don't care about any other axis. I just want to change the height. So we're going to use a set vector component and connect the vector and set the height, the y-axis, connect that to P. And now we're getting a little bit of displacement. Now let's increase this to see that. And I'm going to change the frequency so that we have big displacement, big noise patterns. Cool. So we're starting to see some kind of terrain already. And this is exactly how the terrain tool works. It does exactly the same thing, but instead of does it on a terrain tool, on a grid and points, it does it on voxels. So let's hit tab, and if we look at the tab, it's called terrain. There's all kinds of nodes related to processing these volume fields. And so we're going to create a height field, which is the base. We'll always need a height field. And then everything else you see here is processing that height field. So we're going to create a height field, and if we look at that, we have basically the same display. It has exactly the same look, but if we hit W, we don't see anything. It's actually there's no wireframe or anything. And if we middle click, you can see it says 2 volumes, and which means is it's a 2D Houdini volume. It's not VDB volume. And if we look at the fields here, you can see we have one field called height and another one called mask. And see these 2 numbers? We only have voxels in the X and Y, in the Z and X in this case, and the height is 1, and because of the orientation. And then we're going to process this, and Houdini will be able to displace it up and down. Now let's create a second node which is called a Houdini, a height field noise, and this is by default. This comes by default with the height field. You can see we just added the node, and it basically started deforming the grid for us, deforming the height field. This is great. It's looking cool. And let's take a look. We have 500 by 500. Let's increase the spacing. And the grid spacing here is basically the voxel size. And the smaller the voxel, the more details we're going to get in this field. And so now we have 1,000 by 1,000 subdivision. So now let's try to do the same thing. Let's say we're going to put 1,000 by 1,000 here. Okay. And how much we have? We have 1 million points. And let's displace them. Now this is cool. It went really quick. But if we look at this displacement, it has a lot more details. And the noise used here is very different than this one. It's the noise used in this node is actually called unified noise. And if we dive inside and hit tab and go under noise, there is these 2 guys. There is a unified noise and a unified noise static. So let's try this guy. And let's connect that. And then let's add this to the value here, and let's use a small, and let's try to match the noise type. So if I hit Alt, this is a shortcut that I have. If I hit Alt D, if you go under parameters and channel, Alt D to duplicate, it gives me a floating panel of this. And I made it always on top of everything so it can copy the values. So we want to change it to hybrid, and the type is what's called sparse convolution. And let's take a look at the grid. Cool, now we don't see anything. Let's try and increase the value. I'm going to copy this because it has different values per different amplitude per axis, so I want to change that to be the same all the time. Okay, cool. Let's set this to 500 and see what we get. Cool. Now we're getting something very similar to the terrain tool, but let's do this, if we change a value, let's change this, look how much time it's going to take. See, it took almost a second to do the change, and this is just with 1 million points. Let's try the same thing with this guy. It's not very visible. Let's try it. See, the change is almost instant. Actually, it's instant, yes. And if we try and do the same thing here, it's not. We're not going to be able. We're not anywhere near that interactivity, which means we can push the quality much higher with this, along with having all the extra features of using a 2D volume, using volume to combine fields and stuff. So let's change this to 0.1, and this is going to make the resolution really high. And if we look here, we have 2000 by 2000, so almost 4 million points. And now we have our terrain working, and let's try and increase it. Change. It's slower, but it's much faster than anything else. And now we can, let's go back and change it back to 1. We can start playing because it's interactive. It is much faster to work with. We can start doing all kinds of terrain tools, but we're not interested in terrain specifically. We want to learn primarily from this week. We want to learn how to create different heights, different interesting materials that we can use in the environment, and I also want to use it as a visualizer for what the noise does to the surface, because looking at the noise patterns in just a 2D, a black and white image, is not a very good indicative of what's going to happen to the surface, especially when it comes to negative values. So I want us to try and learn how to use the tools to visualize the different noise available, and we're going to be primarily looking at the unified noise this week, and then the unified noise is a combination of different noise combined together. And so hopefully by the end of this week we'll be able to have a very good understanding of the different patterns available in Houdini, and also create some very interesting material. And let's get started with that. So let's continue with the patterns and understand how to use them with the terrain tools. And we're primarily going to focus on this height field noise, along with mixing it with other nodes as well to process the data. So I'm going to change a few things here, and the first one I'm going to turn off is this. I'm going to turn off this hybrid option, the fractal option. I'm going to turn that off, and I'm going to change this to Worley F2 minus F1. And you can see already that it's creating very interesting shapes, and this is the base start for all the rocks that we're going to be creating pretty much throughout this workshop. So I'm going to change a few values here, and let's change this 250, I think. Cool, something like that. So we see already we have very interesting cracks, we have very interesting heights, we have these very cool flat areas that we see in rocks. It has a lot of good interesting visuals that we can use. And the next thing is, I don't like how this is very uniform. So I want to distort that. I want to break all this uniformity. And with the terrain tools, we have something that we can use for that. It's called height field distort. Cool. So let's connect that and take a look. And by just plugging that node, it already is doing an amazing job at breaking these lines. And this is very, very powerful, because we can work on a low level, define the rocks, define the shapes and size and everything, and then we start layering things on top of that. And I really like just the result of this out of the box. And let's try and play with the values here. So you can see it's not changing the height. The cool thing about this, it's not changing the height of any of this data. Actually, if we look at it from this angle, and reduce it to 0. Sorry, set it to 0. You can see the elevation is pretty much the same. As we start increasing it, it's just shifting things in the X and Y axis, and this is very, very cool because we don't have to mess with our height, and it helps to know where to add the details correctly, especially with these flat areas, as they will get less distortion. We can also reduce the size, but what I would like to do is, because this is super fast to compute, I'm going to layer a few different ones. So I'm gonna have that, and then copy this and reduce the size, add a little bit of offset, and then we're going to reduce the amount, something like that. And we can also, there's two different options here, and we can change between them. We can choose the roughness to make it sharper, make the distortion sharper or softer. It's just softening the noise or giving it more contrast. Cool. So now we have that. Let's layer something else. Let's add another height field. Let's type in noise, and this is the node I want. So let's add some more noise to this, and this time I don't want that Worley noise, so we're going to leave the default options, and I'm going to reduce the amplitude as well as the size, something like that. And you can see already we're creating some very, very interesting rocks with just couple of nodes. And if we go back, let's see, and start changing this, we can see we can get much more. We can change the size of the rocks and do something like this, for example. You can see we have some very cool patterns here. Now the cool thing about this is we can layer stuff on top. We can combine them. So if I add another one, I just copied the same node, but I don't want the same node. I want the size to be bigger, and I want them to be higher. Okay, you can see already. Maybe let's change the order, even though it's not gonna do much. And now we have very interesting rocks with small rocks on top of them. And let's try something else. I want to reduce the noise, the height of this, and I want to add another level of details to this. So after all this noise, I'm going to copy this, paste it one more time, and let's create the pattern even smaller. Let's make it 10. And let's give it a size of 5, an amplitude of 5, maybe 6. You can see now we have a lot of interesting patterns happening with this environment. Now let's try something. Let's increase the resolution to 0.5, and boom, it's done. It's already done, and now we have much higher resolution. Let's go even crazier. Let's try 0.2, and this is going to be I think a little it's not too bad. So let's take a look. Cool. So we have a lot of interesting rocks going on here. So the good thing about this tool is that we can easily visualize any noise patterns we want. Now we're still using these guys, but we can easily create our own volume VOPS and modify the height field the way we want. Let me check what the next example is. Cool. So in the next example, we're going to build something similar, and we're going to learn how to process this data even further to create something more interesting. So now let's continue and learn a new feature with the height field that will allow us to create a lot of complex effects. And I'm going to start with a height field, size of grid spacing of 1 and size of 1K. And I'm going to create a height field noise, connect that, and I would like to start with our Worley pattern. So this, and let's increase the number of rocks, and let's reduce the height a bit, something like that. And then we're going to distort that. So same thing, height field distort, break those edges. I'm gonna leave it at the default, and let's add some more noise. And let's take a look at what we have here with the noise and stuff. So the main option is set to sparse, convolution, and hybrid, and let's reduce the size. And you can see we're getting a lot of interesting details. Actually, let me turn this off and this guy off, and you can see with this unified noise we can create some very interesting layering. So it's basically, this is the base layer, and then there is another noise on top of that gets added. And the most complex one is the hybrid terrain. And then these are all the bases that we can use with the terrain. This alligator, and we can create all kinds of interesting results with this. So let's change it to sparse, and let's keep it at that. And let me uncheck these guys. Cool. So I like this. Let's keep it. Maybe let's reduce just a bit. And what I'd like to do now is I'd like to clip this data. I don't want it to be all the way from start to end. I want to clip it. And the height field can easily do that. And it will do it in a very smart way, not just a raw clip. And if we type in clip, there's a height field clip node. If we just connect that and tick on compute range, and it will compute the min and max because each height field has its own. And then let's see, so let's turn on min clipping, and at first it doesn't do, it's matching the min, and as we start playing with the values it will start clipping the data, but it doesn't clip it just blindly. It doesn't clip it all at once. There is a nice transition, there is a very smooth transition, and we can change the masking to show us basically the edge of the clipping or the bottom of the clipping. And let's turn that off just for the visualizer. And this is the feature I like the most. This soft clip here. This is where the volume stuff comes in. This is something that you can only do this nicely with a volume mixing. So let's clip the min, and let's clip the height and see what we get. And this is what I was looking for. I wanted to create basically some kind of bricks that are sticking out of a wall or something, and we can create some very interesting, a thin height. It doesn't have to be too thick, but it adds a lot of details. And the cool thing about this is we can analyze the various area. So I can say, let's see, I will do that. And okay, let me show you this. So the cool thing about this is we can isolate the top part from the bottom. And if we hit tab and type in mask by feature, or mask by feature, and connect that here, it will automatically analyze the volume and give us all kinds of information that we can use to mask the different areas of the volume. So for example, right now it's masking it by slope. I can turn that off and say mask by height, and then let's find we can hit compute range, and it will find the min and max automatically for us. And let's try and isolate that. Cool. So we can create a mask for just these parts and or a mask for just the bottom part. So something like that. And this way we can use this information in the shader, and it's actually very, very interesting. Even just these cracks here, we can export that as maps, and it will look really cool to use in any shading operation that we want. Now let's try and add more details. I like what I have here, but I'm gonna copy it. I want to create something more interesting. And we're gonna come back to the mask bay feature, so don't worry about it yet. And let's increase. I want more pieces, and this is the stuff I really like. You see here how the kind of pieces are combining together, and this kind of detail here, the merging of edges, you will not get this with surfaces. This only happens with volume. And this map already is very, very interesting to use in, on a ground displacement, and then you can use this information for masking. But these cracks here that opens and expand and get thinner is really, really cool. Now let's play with the noise a little bit more. Let me save this in case you guys wanted that. Let's leave that as it is. And let's add a little bit more distortion. Very cool. And you can see how the kind of details we get here. I think it's too much, so let's reduce the amplitude. Cool. And now that we've clipped everything, we can start adding more noise as well. But let's play with this a little bit more. This is the second noise that we're adding on top. Yeah, I really like this. Very cool stuff. And let's see with the clipping. Now see that the stuff at the top is not completely gone. It's some stuff is still there, and we can choose to clip that if we want to. Soft clip. Yeah, we can turn that off, and it will be raw from 0 to 1, or we can turn it on and then we can reduce. It looks like I cannot have. Okay, yeah. So you can see how it can control the edges of the clipping. And this is the softness as well. So you guys can play with these values to understand what's happening. And now next to the into the next part, I like this mask, but I want to copy it. I want to leave it at that, and I'm going to invert it. So let's take on invert, and now we're masking everything at the top. And let's create a new noise. Let's create a noise. And this time I want to apply the noise to everything. And my noise type is going to be a Worley. I still want to add that, and it's going to be really small. And let's add even more. Let's add more. I want to turn this off. Okay, something like that. And let's reduce the amplitude to 2, maybe 4. And let's add a little bit of noise. You can try different combinations. Here, let's try this guy. Okay, let's keep it at that. But now it's applying everything to all the areas. Okay, and I don't want that. I want to mask it. So I'm gonna connect this input to the second one, and boom, it already analyzes the data that we have. We can clip it even more. Let's try a narrow, yeah, something like that. And this is very cool because you can see it's softening, it's creating a nice edge around the box. So let's see what we get from that. Cool, we still have an unharmed edges, so that's very cool. And then we can increase the height maybe a little bit more. Let's try 10. Cool. It's just an idea. I'm still not super happy with the result. So maybe something like that. And let's increase the let's reduce the size. So yeah, something like that. I wanted to have the two surfaces be very, very different. And I think I've done that. So let's try and increase the resolution to 0.2, which is a crazy value for us. And now you can see there's a lot of details there. So let's make something reasonable. 10, height 2. Cool, something like that. And we have some kind of sediment on top. And for this guy, we can also mask it, which is here. So let's do that. But let me first reduce the, increase the resolution back. And let's create another height field. Sorry, a noise. That's what I meant. And let's try, see what we get. Cool. And let's connect that. And it should only affect the stuff at the bottom. Cool. So let's increase the size. And yes, it is affecting only this. And what I'd like to do is I want to add more cracks there. I want to add very fine cracks into those lines. So I don't want this. I don't want the hybrid. And I want the Worley, something like that. And see this operation here, this is very important because it decides how it's going to blend these two. And right now we've been adding everything. We can subtract the volume, we can push things in, we can find the difference between those two, but the difference is going to use the world space position as well. So in this case it's not gonna work. You can multiply the two values, you can find the maximum, which is in some cases very, very helpful. You can find the min between the two, which didn't produce anything, or you can decide to blend between the two using a specific percentage of your own. And let's go back to, you can also choose replace to completely erase that data and add a new one. But because the position of this field is in a is at this level, and all these fields are at the bottom, that's why we're getting this stretching here. So let's add the stretch, change the mode to add again, and I want to add a little bit of distortion. So height field distort, but I don't want to distort everything. I want to still distort this, only this stuff, only the stuff in there. And let's reduce the size. And let's do something like that. And let's see what else. I want to reduce the height, so let's do it from here. Something like that. I just wanted to add a little bit of variation. And now we have a very interesting surface that we can use. We can also analyze, so let's do that. We can put down a height field. Let's call it mask by feature. And this node takes any height field data and analyzes it. And we have different options. We can analyze by slope, basically the slope of the surface. And with this guy, we can create all kinds of interesting maps to also export and use in the texturing process. So for example, I can export this as a 2D map, and use it to drive or combine different materials, for example. So that's the slope. We can use the height, which we have already done. So let's compute the range. And you can see how cool these cracks are. We get very, very interesting details. And these guys by themselves can be used as a texture for a variety of things. So this This is an example. And by the way, I changed the viewport from shaded into black and white to just look at this. And it's really, really cool what kind of textures we can create just using a simple volume in Houdini. The next one is by curvature, which we don't have a lot of curvature. It's not going to show up too much detail in this case, and or if it does, it's going to look very messy. But the cool thing is we can combine. Once we export the data, we can multiply different maps. So let's say this guy has interesting details in the negative areas. We can generate another one by height and then combine those two. Let's say invert this. We can, in the shader, just combine these two and multiply this mask here to be only in the red area but not anywhere else. So we can use these this information combined together. Now the direction is also very cool, and we can easily add all kinds of details. Actually, let me do this. I want to show you guys this. So we have our surface. We added a bunch of noise and stuff to it, and then I'm going to analyze the, let's see, it was showing me the map. What happened? Okay, so you can see it's isolating stuff. The face is binormal, so anything that has an angle of 30 and an angle spread of 30, it's going to isolate that. And we can change the goal angle, which is basically a rotation along on the y-axis, so it's rotating the map. So let's do this. Let's create a mask like that, and then let's rotate this all the way, something like this, and create another mask. And what I want to do is I want to create a height filled noise. Okay, and this is the noise I want. I want to distort this guy, and here I'm going to show you guys something new. So let's reduce this, the noise, and then under processing here we're going to under these two guys. I'm still not, my head is not fully wrapped around this, but we can easily create some very cool stuff with it. So I'm gonna take on this enable lattice and enable gradient warp. And if we start rotating this, if we start moving that, let's reduce this guy. Okay, let me connect this to the original plane so you guys don't get confused with this. So if I set this back to 0 and let's turn this off, you can see we have a normal surface like as usual, and if I turn this on, it's going to start distorting this map. But the cool thing, there is this gradient warp here which does some very interesting warping effect, and you can see already that we're getting a lot of small rocks pushing and small pebbles and things like that, and this is really, really cool. And let's change this to F2 minus F1, and it's basically, it takes the existing noise and repeats it, and then it does some kind of distortion on top of that. So let's change it back, and this is the noise I want to add, and instead of adding it to everything, I want to add it and mask the noise by this guy. So let's lower the height and let's reduce the size. So something like that, maybe 10, 20. Okay, 20 is good. And let's connect this now. Boom. And now we have some very interesting patterns being pushed by this field. And let's do the same thing here. Let's connect this guy and use the second map, and let's add the details on the other direction. But let's change the noise. Let's say we want to shift it, and let's set it to 5 and maybe the details to 80, so we don't get the same pattern in both sides. And let's set this to 10, and now we have some very interesting details on by analyzing the existing mesh. Now let me increase the resolution and show you guys what we get. Let's go to 0.4. Cool. So everything is looking great, and we have a lot of interesting details everywhere. This noise, I believe, is it's affecting this area. But you can see we have all kinds of interesting details happening. Now let me run one more time the height field mask by feature, and I want to show you what the curvature can create now. So the slope is also very cool, but let's try the curvature this time. And let's tell it to compute range. And now we have some very interesting details in there. And let's play with this guy. Let's move this up and move this down. And let's move this point. And now we can get a lot of cool details out of this map. And the last feature I wanted to show before I stop this video is how we can convert this into a mesh, which you guys probably are wondering. And I cannot stop tweaking this, but I have to. Cool. So how do we convert this? Well, there is a node called height field convert, or convert height field. And let's be ready. So it's 25. It's going to take a few seconds, but let's wait for it. And done. Yeah, I think the computation is done. It's just displaying the geometry now. Done. Now if we hit wireframe, we get a perfect quad mesh containing all the details. We can use this straight with rendering. How much is it? It's 6 million. So it depends on your scene. Maybe you have a close-up element and you want to use this, you can definitely use that. And that's how you convert geometry basically. So now we're going to learn about a few more with the terrain tools and learn how to create some displacement that we can use to add details to our assets. And I'm going to start with the same height field. I'm going to copy that. Cool, and now we have our height field, and I want to add a little bit of noise to the surface. So let's do that. Let's add a height field noise. And let's change the type to F2 minus F1 and the fractal to standard FPM. And this fractal has it has a lot of recursion happening, so you get a lot of big shapes, mid shapes, and small shapes once you add this deformer, this fractal type combined with the Worley noise. And I want to tweak a few things here. Let's change that to something like that. Roughness. And let's reduce the size, the amplitude, sorry, and the size as well. So something like that. And what I like about this is we start getting more breakups into these instead of just this, we get an iteration, a second iteration and a third iteration trying to break this Worley with a similar pattern. You can see some very interesting cracks. Cool. So let's add a little bit of distortion. Okay, maybe reduce the size. Something like that. And let's add a bit more noise. I want to make the surface more rougher basically. I'm gonna add this one, and I'm going to not have a lot of deformation going on, and then we can tweak it. I just want to have it there because I know I'm gonna need it, so I want to reduce this, something like that. And then let's see, let's not do that yet. And the main thing I'm looking for is I want to create a map that I can use in tile onto a mesh to add fine details, to add extra displacement that I can use as well, that I can use the displacement as a mask to vary the shader in my object. And let's see, so I want to create a clip node, not this one, height field clip, and I want to clip these details. Similar to what we did, let's compute the range, and let's start clipping. Start with a min first. Cool, and let's reduce this down. And the cool thing is, with the clip, actually let me do one quick example to illustrate something with the clip. So with the clip I can do this. I can reduce this size, the number of points. I can reduce the element size, and then let's turn these off. And with the clip I can remove everything except the ones at the top. So something like that. I don't need the max clip actually, I need the min clip. So something like that, and let's remove this, and we can do something like that as well. And let's remove the mask, I don't want to see that. So there is a node called height field clear, layer clear or mask clear. Let's put a layer clear, that's fine. And we can select the field that we want to clear. It's the mask in this case. And now we have a display. And what I like about this is we can just create few rocks here and there, and we don't have to have a high density because we're just isolating those guys. We can do tile this, and we won't have any issues as long as we don't have things that are very close to the edges. And we can clip, make sure we can make sure the clip is solid, and then basically we have some rocks now. So let's lower this, and let's lower this guy as well. I want to pick a different section. And you can see the lower you go in, the more you're gonna get because of the way we're clipping the data. And you can always play with this to decide what you want to do. You can also select the bottom part and flatten it as well. And so this is one example that it would be nice to be able to tile this. And I'm gonna go back to this example, and let's clip it. No need for a soft clip, so I want to make it sharp. And let's go up a bit and up here. Okay, cool. Something like that. And let's clear the field so we don't have to visualize that. But now we have rocks everywhere. So this is great, but what I would like to do is to add a region, a circle at the center, and hide everything else. And the way we can do that is using I prefer to use a geometry, and we're going to learn something new. So I'm going to create a geometry here, and let's make this sphere bigger. And let's change it to polygon. Something like that. And let's move it down. And we can just set it to a primitive. And then there is a node with a train tool called height field mask by object. And if we connect that and this, and then visualize, now we have a perfect mask. And this is awesome because we can have any kinds of geometry and use that to mask or add details to the surface, and it's something we're going to look into in a couple of videos. But for now I want to use this just to mask, and we can blur this result. Okay, it doesn't have to be perfect. And then the next thing I want to do is now we have this, I want another copy where this is flat, where this plane is flat, but I don't want to use the original because the original is in a different height. So I want everything to be flattened at the lowest level here. And so I copied this this clip here. Actually, let me make sure I copy the correct node. So I copied this clip again, and I'm going to set the min to be the same value for both. Okay, and let's make sure the soft clip is set to 0. So now we have a flat plane at the lowest level. And with this mask, we can, with this information here, we can use it to mix between this guy and this guy. And actually, let's clear the layer as well, so we know we have just a flat plane and we have the deformed plane, which is this guy, and then we have our mask. Let's call this mask. Let's create a null and call this main, just so we understand. And let's create a null and call this flat. And there is an awesome node called height field layer, and this node allows us to mix between different height fields. And I'm going to connect the first one, the second one, and then connect the mask. Now if we look at the result, it's blending between the two, but it's doing the inverse operation. So I'm going to take on invert mask, and now we have this map. And this is awesome for us to use in any place we want, any software. We can use this in ZBrush to add, those to basically stamp details onto geometry, and we can control this. We can change the radius, make sure that we don't hit the edges. We can blur the region, something like that. And the cool thing I like about rocks is this feature, this transition here, is actually really, really cool because it feels realistic. It's not just a straight cut off. Now, I think this is great, but I feel like the blend is a little bit too uniform, and I'd like to distort this. So I'm going to add a noise, and with the noise there's a height field mask node, but let's create this node, and let's also create a noise, a height field noise. And if we look at the two, they're actually the same node. One is operating on the mask channel and one is operating on the height field channel, which is what creates this displacement. So it's pretty much the same node, just operating on a different channel. So let's connect this guy, and let's use a different operation. Let's say multiply. Something like that. Cool. And now we have our distortion. Let's try. Yeah, let's leave it at that. We can also do a curl, a distortion. So we can connect a distort node, and right now it's distorting the height field, and we can change this to mask and distort the mask. So let's take a look at the mask, and you can see already it's being deformed. So we can change it like that, and let's connect this guy and take a look at the result. Yeah, boom. And we're not hitting the edges, and we can have much more breakups in the edges, even something like that. And we can easily tile this now, and it won't be causing any issues. Now, if you want to squeeze in more data out of that, we can easily use a box instead of a sphere. So I connected a box. I just put down a bound node on top of the sphere, so we keep the same size. And now we have a box, so there's more details here being captured. Cool. So the next thing I want to change is I refrained from adding details with one of the noise, and I want to go back and start adding that. So let's do something like that. Cool. And let's try and add more rocks. And we can increase the amplitude, and you can see as it goes, as we change the height, it's clipping because we're pushing stuff out. We're changing the height, so whatever area we're clipping is not changing, and it's giving us new values. So let's see. We obviously have to tweak the clipping, but we can also keep it and see what we can get out of this. So these are just some ideas, and the possibilities are endless, as everything else in Houdini is. So you can see with just a couple of tweaks I've made completely different rocks, and I've lost the original one that I liked. Something like that. Cool. Okay, so let's see what's next. So what I want to show you guys next is the processing the height, the masks that we have here to using another node. So if we didn't like a mask, if we say it was too sharp or and too crisp, and we wanted to blur that, there is a node called blur height, blur mask, mask blur, height field mask blur, and connect that node, and it does the blurring for us. And this is an awesome node because we can easily do processing, which is something really hard to do in SOPs in general and very time consuming. And with this, it's really, really flexible to do that. And the other node I wanted to show is this blur as well can be applied to the height field itself. So if you have details, if you have a lot of details and you want to blur in certain areas, you can definitely do that. And you can see how this is amazing. This is really fast. Cool. So what else? Let's look at the erode operation. So we say we have this field, we have this information, and actually let's add a bit more rocks. Something like that, and let's add something like this. I really like this because you can stamp them, and see this transition here. This is really cool because you can just put them scatter them on the ground or something, and it will add this displacement. You can use all kinds of masking with this, and let's do that. So I'm going to show you the erode operation, which is basically an erosion simulation that happens on the field. There's a lot of settings. I'm still not so sure about all the options yet. I need to do some wedging, but maybe you guys can also look into this. And all you have to do is where's the layers? All you have to do is basically hit the sim button, but you can tweak a few more things at the beginning to get different results. And right now the visualization is interesting. Yeah, the range of the field is definitely in the negative, but I think, yeah, let's hit play and see what we get. So if we hit play, it's going to run a sim on the fluid, on the volume field, and you're going to start seeing new types of erosion line. You get rivers, you get bedrocks, you get all kinds of information that we can use, and it's basically looking like a terrain now. This is an erosion being run onto the sim, and this is really cool because you can see we get all kinds of crazy details here. And actually let's let's do something. Let's increase the resolution, and maybe I'll have to pause the video, but I want to do this. So let's run a few more frames and I'll show you. Let's wait for it. I think it's not too bad if we think about what's happening right now. You can see there is all kinds of details being generated, all kinds of cool fine lines here, and we can control all of this. You can control how much water there is, you can control how much precipitation happening, how much debris, and I highly recommend that you guys take a look at that and see how those options affect the result that you get. Now what I'm interested in is the field that this creates, and if we middle click here, we see that we have a height, a mask, cliff, and mesa. And then if we look here, we have some new stuff, and this is really, really cool because we can use that information to control various things. So let's take a look at these guys, and here, yeah. So now this surface, yeah, because of this, now I'm seeing the result of this node. It had a preview issue, but now you can see all the cracks, all the flow lines, and the river. The blue is the river, and the brown is the sediment and the rocks. You can see we have all kinds of cool details. Now obviously you can use this as a terrain if you want to, but the goal is to use it to create rocks for us. So let's see, I want to visualize different fields, and with this node, remove tinting. Yes, so this is what I want. And here I'm going to change it to flow, water, and debris. I'm trying to visualize, and it looks like there is some issues with the data, or I'm forgetting how to do it. Okay, so let's turn this off. Yes, this is, sorry. We need to set this to custom tinting, and the area that we're going to visualize our data in is the heights, and then we can visualize all these guys. So for the debris, look how awesome this is. We have all kinds of cool stuff, and we can export all this texture, all this information as texture. We have flow lines, and we have also direction and that we can use to create some more interesting particle sims. We don't have masks, mesa, and then water. Cool. So let's take one super quick, and let's say we want the debris. Okay, cool. So let's create a noise. And it's visualizing everything now. So let's remove the visualization from this guy. Change, remove tinting. It still does not, I don't know, it feels like there's a sorry, both of them needs to be set to remove. Okay, cool. So let's add that. Let's add some noise, and let's add distortion to create some interesting details. And then I want to mask that with the debris field, for example. So here we can go into the mask, and we need to connect it. We can connect it to the same input, and then we set the input to debris, and now we're masking everything by that information. And let's reduce it so we have something reasonable. And now we're adding just noise into the field onto that field. And I think it's too much, so maybe something like that. Cool. You can see now we're affecting just those cracks, and see how awesome this is. And now for the final part, we need to convert this into a map, a geometry if we want to use it as a surface. And then for the map export, we're gonna look at that in the next video. So let's take a look at the surface before we stop, and then we'll continue in the next video. Cool, so this is our final surface from with the height field converted with all the details that we need. We also have all the attributes needed, all those attributes converted into point attribute that we can read on these from here and use them in shading this. In this video, we're going to take a look at how to export the data into a texture file. And the first thing that we've done so far is take this volume field and convert it into a geometry, which is great. But the goal from this week is to create actual textures that we can use to either as a bump or as a displacement, or to use them in sculpting. And we've done the conversion of the geometry, and let's take a look at the attributes that we have. Let's put down a visualize node. And we're going to take a look at one attribute just to make sure that we have everything in there in the geometry. So that's the visualize node, and if we go under visualizer, the attribute that we're interested in, for example, is the flow. And it is a color attribute, so let's take a look. And we should see the flow line. So that's our information. And if you want less details in the final mesh, you have to go back and resim, or I believe there is a resample. So there should be a resample node. So let me drop that in because it's a volume field, and right now it's 1K by 1K. So let's scale the resolution to 2. I meant divided. So 1K, let's go even lower. And now we can convert that. And you can see we have less detailed geometry. Now when it comes to games, and if you want to create something more high res, we need to extract the displacement difference or the normal map between the low res and the high res. And hopefully towards week 7, we're going to be able to do all of that stuff. So here we can connect the same visualizer, and we should be able to see the same information as well. But because we have less point, it's going to be less accurate. So this is for the geometry, which is great. We can just save that to disk and we're good. For the height field, we need to save it to disk. So let's say $hip/tex, and let's call this terrain a.exr. And we can use any format. In this case, I'm going to use exr, and you can specify the resolution. So let's say 2K, and let's leave it at let's do 16 because we don't have a lot of information that requires 32-bit precision. And then here, which is an awesome feature, and because all these guys are a float information, we can say, okay, I want the red to be the height, the green to be the flow, the blue to be the water, and then the last one would be the debris, for example. And for the remapping, I'm gonna set it to auto remap, which means it's gonna fit automatically the range of each of these channels. This is mainly interesting for the height. So let's write this to disk, and let's take a look at it. It's saving the file here, and in the meantime, I'm trying to find the folder. So almost there. Cool. So this is our map, and it's a 2K map, and it took a couple of seconds to save this. And if we look at the red, this is our displacement map. This is our green channel, and this is our blue channel. This is the alpha channel. And we can put a lot of information into one file instead of separate files for each one. And now let's say we have this map. I'm hoping that it won't crash. And I'm going to create a grid, and let's change the size to be 100 by 100 and the resolution to be 250 by 250. We've done this in week 2, but I'm going to do it super quick again. I want to read the texture back in and use it to displace the surface. So I'm going to create a UV texture node, actually a UV project, to add a 2D coordinate, UV coordinate. Connect that, it's a point attribute, and let's create a color map. Let's connect a vector. Let's export this, and we want to set component, not set layer components, but set vector component. We want to change the height, and the height is going to come from our EXR channel, and let's connect it to P. And here we actually need just the red channel because the height is only in the red channel. So I'll put down a vector to float, and we need to make sure that this is RGBA. And to be consistent, let's put vector 4 to float because we have RGBA. Okay, cool. So let's read the map. And let's make sure we're setting the correct component, which is the height. And it's not very visible, so let's multiply that by 10. It should be a reasonable ratio. It looks like not because of that remapping, could be. But this is the result applied. I will look into the remapping, but I think this matches this guy. I know, because it's not at the same position. Yeah, the remapping needs a little bit of tweaking by hand, but you get the idea already. So let's increase this to 1000 and 1000, and now we have our surface displaced. And we can do this at render time. We can instance it as well. And that's pretty much it for saving files. So now we're going to look at creating something more realistic, and we're going to create a wall made of bricks. And to do that, we need to learn a bit more about the patterns available for us with Houdini and with the height field. So I'm going to copy this, kind of set the resolution to 1, and we're good. It's this one. And then if we go under the terrain, there should be a height field pattern node. Cool. So let's create that, and let's take a look. And these are all the procedurals available in Houdini. So let's actually reduce the size to get more details, and let's set the height to 5. And this is a great visualizer because we can see what's available and learn how to use it. So this is a ramp, for example. You can see we're getting a stepping effect, and you can play with the ramp to control that, to control this. And you can change the repetition, the number of repetition on the pattern, and you can play with the transition, the interpolation mode of the points. And this is the thing I was talking to you guys about. When we see, especially with ramps and linear things, when we look at things in black and white scale, let me change this. Let me copy this and create let's say I want to put this into a mask, so instead of the height field. And this result now, it's hard for us when we look at this, it's hard for us to say, okay, this is going to be displacing this geometry this way exactly. And especially that the values can easily go higher than 1, then we're not going to be able to visualize them anymore. So the range of the visualization that we have with our eyes is limited to 0 and 1 because of Houdini and because of the color display. And so it's very important, for example, when we look at this, it's hard for us to say, okay, I know exactly how it's going to displace the surface. But in reality, none of us do. I mean, we can get an approximation, but exactly how this interpolation is going to work, it's really hard. And once we start doing things like that, it's hard to understand what's going to happen to the geometry. And so let's play with this a bit more. So this is the height, for example, and this is the ramp mode. We can use EXP ramp. I'm still unclear as to what this is doing. It looks like there's an exponential, yeah, it's an exponential ramp starting from the center, and I believe we can phase that to have something like that. And let's see, the next one is stripes, which is what we're going to be using. So you can choose the stripe width and the stripe size, and it will start repeating as well. Cool, so that's the stripes. We can offset them and we can rotate them, which is really cool. And actually let me show you something. So if we take this and copy it, sorry, not copy it, I want to create a height by field, height field mask by feature. Sorry, with the names and thinking and working, it's sometimes gets too much, but it's all good. So I'm gonna compute the range, and I want to mask the interior, okay? And I want to add patterns to that. I want to distort that, and I'm going to create another height field, another pattern, and I'm going to rotate it along this axis and repeat it much more, and maybe lower the width. And then I want to mask these two. Okay, so I'm going to use this as the mask, and now we have that. And I can put a layer. Sorry, I don't have to put a layer. This is what I wanted to do. So now we can add in between this a different ramp. And if we increase the resolution, we should be able to get very interesting details out of this. This is just one example. Cool. So let's continue. We're back to the height field, and let's change this. We have stripes, we have stars. We can rotate them, of course, and we have cells, which is really cool because we can take these cells, subtract, and change the width. Something like that. And then we can add some distortion, and boom, we have a ground. We have an interesting pattern that we can use to create the ground, or at least add cracks onto something. Cool. So what I want to do is I want to use the stripe pattern to create the bricks. And I'm going to create the pattern node. Let me change this back to 1. And I'm going to set it to stripes. And I'm going to set the height to 10. And the stripes width to 0.5. And now we have this details. Cool. And what I'd like to do is I'd like to add, I'd like to break this into basically blocks, the same brick. Just imagine we have this is brick, and I want to split them into the same size, the same brick size. And to do that, I'm going to add another pattern. So pattern, and this time I'm going to use a ramp. So let's change it to ramp, and you can see it's already deforming the geometry. I'm gonna rotate the ramp so it's 90 degrees, and instead of doing the ramp all the way affecting all the geometry, I'm gonna change it to only affect it in a specific region. Okay, cool. So now we have our original geometry, which is pretty much gone, and we need to add this. Instead of replace, we need to add this. So let's say I want to subtract this -4, and now we are dividing these blocks into different bricks. But it's affecting everything. I don't want to affect these guys. So how can we solve that? Well, we can easily solve it by using a mask by feature. So that's mask by the height. Compute height, and let's find that. And now we're doing just that. Great. So let's do the same thing, but to add, we need to add the extra parts, which is missing. And the reason I left it this way is because I want to offset everything. So I'm going to copy this, and here there is a phase. I'm going to set it to 0.5, and if we do that, let me make sure. Yeah. If we do that, we are now modifying the patterns. The next thing that we need is to offset this pattern as well. So we need to add 0.5 here, and now we're shifting everything. And all we have to do is use a height field layer and combine these two. Just add a straight add. A straight add, let's see. Straight add didn't work. A maximum is going to work. We need the maximum between these two, and now we have our pattern bricks. It may have taken us a few more extra nodes, but this is the easiest way I was able to create this workflow. Now we can easily make this procedural, because I know you guys would want that. And you can link these guys together, the size to be the same, and then the offset needs to be, where is it? The strip size, the width, the stripe width needs to be the offset of the next one. Okay, cool. So the next thing, let's add a little bit of noise to all of this, and I'm gonna add a height field noise. And let's see what we get. And I think that's good. We can start with that. Let me check something super quick. Very interesting. I have a different file on the side that I'm using to compare, and the result is very, very different so far, but I'm not so sure what I've done to be different, what I've done differently. Oh, I know why. Sorry. I know what's different. This guy here, right now, it's very uniform. Okay? And there is this distort pattern, and if we take that on, we can add a little bit of randomization to those lines. We have to be careful, of course, not to break those lines, but we can add that here. So something like that. I think that's still too much, so let's increase something like that, and let's set it to 1, maybe 2, and let's increase the value. So -4, maybe 8, -8. Okay, cool. And the cool thing, we can control that. We can control the crack itself. Okay, and now let me make a copy relative reference, and this will give me a copy that is basically an instance of this. And then let's connect this guy instead. And let's delete this. And here all we have to do, we need to break this and set it to 0.5. And now we have our cracked lines and we have the noise added. So let's continue and add a little bit more details to the brick wall here. And the first thing I'd like to do is, these lines are too uniform. I don't like how uniform they are. And in order for me to distort everything, I'm gonna be affecting everything else, and I don't want to affect these lines. I just want to affect these guys. If we go back to the original generator, which is this, there is a distort pattern as well that we can tick on and utilize. So I'm going to use that, and we have to make sure that we don't break those lines. And by that I mean this kind of stuff, this kind of displacement. And let's increase this, something like that. And let's try this value with this guy. See what we get. Okay, cool. And now I have something more interesting rather than just straight lines. Cool, so let's add more noise. I like this surface, so let's keep it but reduce it a little bit. And I want to add another one, height field noise. And let's take a look. And this time I want to change it to a simplex noise. And this guy, it's a very interesting noise, and I can get some nice carving out of using it. So I'm going to reduce this here. I'm going to change the mode instead of add to subtract because I want to remove data. And look, it's happening. You can see how it's pushing stuff out. This is really cool. This shape here is really cool. So let's reduce this guy. And let's reduce the size element as well. And you can see now we have carving inside. Let's turn off the center noise. And you can see how it's pushing the details in. Let's increase the resolution to 0.6 to get a better preview. And this is what I'm looking for basically. Cool. Let's try and add a little bit of distortion here, and we should get some more. We'll talk about this more later, but this is an incredible feature. You can see already what kind of details we can get. I don't think it's working well. I think we can make good use of it. So let's leave it at that, and then let's tweak this more. Cool, something like that. Yeah, this is what I want. And let's reduce the value even further. So let's set it to 2. Yeah, I think something like that. Cool. I like this, and I think we need to break these lines. We need to break the main lines here. And what we need to do that is we need to an easy way to isolate this. And this have gotten really complex by now, and there is a lot of similar details. So whatever we're going to use to analyze this, the slope, the height, anything we want is going to isolate, is not going to be able to give us this details. And the easiest way to isolate these guys is by creating custom ramps, and luckily this is a repetitive pattern. So what I'm going to do is I'm going to create another height field, or actually let's take a look at this. So let's create another height field pattern. Let's start from scratch, and I want to create a mask from scratch. And instead of doing height field, I'm going to generate a mask, so we can just change the name in there, and now we can create the details that we want. And for the for the pattern, I want to use the ramp in this case, and I'm going to set the phase to 0.5 for the first one, the size to 100, and the value to 1. And you can see now we have an interesting edge here, and what I want to do is I want to isolate this edge and this edge. So let's try and let's put a point at the center, and let's isolate this. Cool, so now we're isolating that detail. So let's take a look and see what maps into that. Basically nothing. It's not working, where it's not generating the details what we wanted. And what we need to isolate is we need to isolate this. Let me increase these values. So we need to isolate this region here and this region here. And the way to do it is we need to set 2 points all the way up, and 1 0 here. Remove this guy, add another one and another one here. And now we have the ramp that we need. Okay, now let's add a little bit more distortion to this so it's not uniform. And let's add another noise. I like this one, so let's continue with this. So I'm going to copy it one more time, and I'm going to use the mask now. Now I'm going to make it more aggressive. So see, it's affecting all that region, which is great. And this is exactly the effect I wanted. See that sharp line there? That's what I was looking for. And let's lower this to 5, and let's remove the accumulation. I don't want that at this point. That's too much. Let's try 15, 10. I want more variation. Cool. So something like that. You can see we have a nice breakup, and we can easily improve this as well. So we have total control over the mask. Okay, cool. So now we've broken that up, and we need the same mask. So I'm going to create a reference copy, and the only thing we need to change is this phase. Here, I'm going to set it to 0, and I think we can do a layer field add and combine these two together. So let's take a look here, and we need to add the masks. Yes, so we're combining both masks, and now if we use that, we should be able to, boom, we have our rocks, our blocks isolated. Okay, one more feature that I'd like to add, which is I want to add basically blocks where the bricks have fallen or something damaged them, something happened, like a block has been destroyed or something. And what I'm going to do is I'm going to create a clip node, a clip height field, and I want to remove details. Okay, let's compute the range. Let's remove the min, and I want to do this. Let's create a layer clear to clear the visualizer, and let's clear the mask. Cool. So what I want to do is I want to basically set the max to be the same, and now we don't have details anymore. If I set this to 0, we don't have any more details. But let's set it to 0.5 just to have a little bit of leftover. And let's create a noise, height field mask noise, and let's connect it to the original plane. And let's see what we get. We have this noise, and I want it to be sharper. So let's increase the roughness. And let's see. and I want to replace sorry, I was looking with the specular, so it didn't give me a good indication. Okay, let's try this. Let's connect this to the clip and see what we get. Cool, let's increase the value. And I want to change this to simplex, because simplex gives me a nice range to use for this kind of stuff. And we can see, actually, you know what, I really like this, so I'm going to keep it as it is, and I'm going to copy this one more time, and let's see. And this is, yeah, this is the main effect I was looking for, but I like what we just did. And I'm going to generate another mask. I don't want the same one. And let's try 3. Very cool. And with this clip now, I want to set the clip to 0. Let's compute range again. Okay, so minus 15. Because everything got pushed. And let's try. Okay, cool. Yeah, this is what I was looking for. I wanted to flatten these areas, and I have that now. So obviously I still would like to change a few things, but I think you guys have got the idea now. And I think the simplex is a little bit too much. So I'm gonna lower this to 1, and this to 1 as well. Yeah, something like that. And I want to change the height of all of it. So I'm gonna clip it one more time. Compute range, max clip, let's say 6. And let's turn off the visualizer. Cool, something like that. And let's clip them in as well. Yeah, something like that. And we can reduce, yeah. So this is the first effect I was looking to add, but because I ran into the happy accident of the simplex, I liked it, so we have it. And this guy, I'd like to make the transition a little bit sharper, so let's look into that. That's too much. Something like that. And then the last thing, we can add a height field transform. And we can scale this, all of it, to 0.5, for example, so it's not that aggressive. And now we have some very cool wall-like material. Let me check the time super quick. Okay, I think we can go a little bit longer. So let me increase this to 0.2, just to go crazy in terms of details. Still cooking. And let's see, I think it's done. Yeah, so it's definitely very high res. So 5,000 by 5,000, and we're still looking at the volume at the moment. And you can see all the cool details that we get here, and breaking the edges of the bricks. I would like to also add a little bit of this into these guys. We can easily add that using the same masks that we used to add the pushes here, and we can also add it all the way back to the original geometry. And you see how that leftover is still there. I really like that effect, even though it may not be that realistic, but I really like that. And we have all kinds of information now. If I put down a height field mask by feature, we can use this node to give us interesting masks to use to vary the shaders and create some extra details into our geometry. We can get all kinds of interesting interesting textures that we can use to add extra details to the surface, as well as use it to drive the shader if we wanted to. And one very important aspect of this, especially this set here, is to be able to isolate these parts. And I think we can easily get that information by using the height. So if we take on mask by height, it's a little bit slow because of the resolution, of course. And if I check compute range and make sure that we are isolating only the bottom part, we can create an interesting mask for that area only. I think that's too aggressive, but I think by now you guys have a very good idea of what I'm doing. Yeah, something like that. So these area would have a very different material, and then these guys would have a different material. And I think that's pretty much it for this video. In the next one, we're going to add another interesting material to this and hopefully make it a little bit more interesting for you guys. So now we're going to continue adding a little bit more details to the brick wall here. And what I'd like to add is make a completely different material for the flat areas. And I'd like to make this to be made of bricks, and then this area here to have metallic beams on them. And I quickly noticed that the parts here are not flat. They're not going to be easy to blend the extra details with them. And I thought maybe I can show you guys something new and different to make a little bit of changes here, and hopefully teach you guys a new technique to add interesting details. So if we look at the fields here, we can do a height field shrink. We can do a height field mask shrink. And this is basically a compositing operation. It's like doing an erode filter in compositing. You can see how the data is expanding, how the pixels are expanding. So let's take a look at the values only. And let's look at the result, what happens to the displacement. You can see that it's creating some interesting layering effect with this mask, and it can start increasing that. And it's creating some really cool details that I like. I like the stepping that we're getting here. So let's play with this a little bit more. So let's lower this to get more room. Okay, cool. And let's see, maybe increase the value here. Yeah, I want to make more stepping effect for this. Yeah, I definitely like this stuff, and it's very complex thing to add. The layering, the stacking of layers is very complex to add, and this is a quick and cheap way to do that. And what we can do as well to break that uniformity, for some reason I can't display the mask here. There's definitely some weirdness with, yeah. So if I switch the viewport, it refreshes. Sometimes I have to close the view and create a new one. So what we can do now is we can add a distort node and distort this a little bit. And let's take a look at the height field result and see how that affects. We want to affect the mask. We don't want to affect the noise, the height field. Okay, cool. So you can see what kind of details we can get with this. Let's change it to curl, and let's reduce it to maybe 8. Too much, something like that. And this is just an idea to basically break up all the details that we have here. And I was looking to get something like this kind of sharp transition. And now we can clip it one more time, which is happening here. So let's just improve this. So this is working nicely now. Let's go down a bit more because we have more room. We don't want to change that too much. Yeah, something like that. Cool. So this is what I was looking for. I was looking to get non-uniform patterns across the bricks and then change in volume. And I really like the push and pull as well that we're getting between the blocks. There is a little bit of roundness here, but I'm not going to worry too much about that. And I really like the fact that we have you can see different bumps based on different levels, and this is really cool. So okay, let's continue and add our details. So what I'd like to do is I'd like to add interesting beam metals here. And what I'm going to start with is using a pattern, so a height field pattern node. And I'm going to create, let me change this. So I'm going to create a ramp. And I'm interested in generating a mask. And I'm going to rotate this mask 90 degrees and change the size to 20. And in the ramp, I can control now the shape and where the ramp happens, where the detail gets generated. So something like that. Okay. And then the next thing is, now that we saw this, we can use it as a mask. Okay, let's do this. So I can put down a transform node, a height field transform. A height field transform. I'm using this to show you guys something new. And I'm gonna I'm gonna offset the height. So I'm moving it. Okay? And then I'm going to use a layer node, height field layer. And I'm going to mix the original one, which is this, with the transformed one using this mask. And let's make sure that our mask is reasonable. So we set the height to 1, maybe 0.2, something like that. And this is what I'm looking for, basically just a stripes being pushed out. And let's make this a bit bigger. And let's just smooth it a little bit. So let's add a height field mask blur. And this is too much, so let's just add 1, something like that. And the next thing I want to add is, I don't want these guys to be, I don't want them to be just flat like that. I want to add more details to these guys. So what I'm going to do is I'm going to I can use the same mask here, and I'm going to create another pattern. So pattern, same thing, and it's connected to the original one. I'm actually going to grab all of these because it's starting to get a bit noisy. So let's move this point here. There is an easier way to do this, but I want to show you guys how you can mix and use the transform node. So let's organize the nodes a bit. Cool. And with this pattern, I want to generate a ramp as well. And I want the ramp to be just in a small section. And I want it to be really small. Something like that. And for the height, let's add just 1. And now I want to rotate this 45 degree. And let's increase the repetition more. Sorry. Let's make something like this. Okay, let's try. Okay, cool. Something like that. And now I'm going to mix these two guys. So layer. Actually, let's add it here. So this is the original result, and this is the height field, and let's just add it. So it's been applied to everything, but I don't want that. I want to just apply it to the mask that we've created, which is this guy. So this is our mask, and that's the result. Let's multiply it a little bit so it's clearer, and now we have extra details added on top of those. So let's increase the resolution because we're creating very fine details and it's hard to see them. So adding resolution will definitely help, and let's make them a bit thicker because I think it's too small. And you can see how we can control the transition, how we can control the shape of the details that we're adding, and this is very powerful. Cool. So the next thing I wanted to add is another detail, and I wanted to add basically stripes along this way in here. So I'm gonna add another ramp. Gonna set the rotation to 0, and this is what I want. Set the repetition to 4. Cool. Height to 10, and let's take this mask here and invert that. So connect this mask, and instead of that we're going to invert the mask. See if we have a mask invert node. We don't have a mask invert node. Okay, let's create another mask then. Height field by feature, mask by feature, and this is our original mesh. We want to mask by the height. So compute range, and let's isolate the bottom part. Cool, something like that. And then 0 maybe. Yeah, that. And let's connect, and now we have details in there, and that's what I want. And let's maybe soften them a bit, lower them just a tiny bit, and now we have very interesting metallic structure. And now let's merge these guys together. Now how do we do that? Well, it's actually very easy to do that. So we're going to use this mask which we generated recently using the mask by height, and I'm going to add a layer node, height field layer. I'm going to connect the first one and then the new detail that we'd like to add, and we should, if we connect that, boom, it's done. And the amazing thing about this is that let me turn off the transformation. It's too much. So I need to keep the transformation because the mask is already generated based on that. And let me transform all this down a bit. So maybe 0.2. This is just a transform. And the awesome thing that I really like about this is the nice blend between these two guys. You get a very nice transition, and it slowly becomes the other material, and this is very, very realistic. Cool. So I'd like to push this down a bit. So let's try and do -0.5, -1. Something like that. We're just pushing this down. Let's go down a bit more. Cool. So now we have nice gaps here. That's probably too much, but you guys get the idea. And that's how we create interesting materials. Now let's see if we can rotate this. Let's see if we can rotate the whole pattern. It's not going to work. We have to go back and rotate everything, and it's going to be a couple of tweaks. Let's see. So let's try 90, and this is cool. This is the pattern I'm mainly interested in. Cool, so let's see this guy. Okay, something like that. Okay, cool. And then the last part is this, which I think is cool. So, but let's rotate it to 45 to 90 degree, maybe 100. Okay, something like that. And then let's see what we get. Yeah, it's much more interesting to have different direction for these patterns. And now we have all kinds of information that we can use. For example, this mask here, we can VOP, we can do a height field export. Oh, come on, where is the height field node? I don't remember the name. Height field output, and I can output this to be a mask that I can use later to shade differently the metal out from the bricks from this, so we can have different controls. And there is so many ideas to what we can do with this. There is an infinite amount of control that we have. We can also look at using the original, this mask here, to add. And you can see how it's adding both of them together. So that's one thing. We can also add the original one, and there is so many options to what we can do with this. Now the other thing I wanted to show is this. So with the height field shrink, with the height field mask shrink, I can create a noise like this. So let's see. Let me reduce the number of points if it ever comes back. So let's set this to 1, sorry, the grid resolution, and let's lower this. Let's copy the shrink node, and let's do a transform. I want to apply this to the main grid, so I want to transform that up. I want to set the scale to be the same, and then a layer node, and let's put a dot here, height field, the original, and let's use this mask. Boom, and now we have something very, very interesting. This pattern is really hard to get using any other pattern generator in Houdini, and what I like the most about this is that we can do this. I can copy this guy, make the pattern really big, copy this node, and layer, height field layer, and I want to combine these two guys. So add, okay, let's see if we get, yeah, so we're getting both results combined, and I can reduce this. And this is again really, really complex to get the sharp transitions here. And you can see we have all kinds of amazing controls for us. And the other thing is we can add distortion. And I need to learn to stop, but I want to do this. So let's distort the mask. Something like that. And let's add another noise and see what we get. And let's change it to Worley. I'm just trying here, to be honest, but I think there is a lot of potential for this technique. Let's add a little bit of distortion. That's too aggressive, but you guys get the idea. Hopefully you guys can figure out something interesting out of this. Cool. I think that's pretty much it for this video, and for the bricks we're going to move on to do something a little bit more complex. So now we're going to continue and start creating something a little bit more complex. And you can see with the existing tools, with the pattern tools, we can easily create some interesting patterns, but the main thing that we don't have is controlling the patterns per element, per block. So let's say I wanted to change the elevation of each of these bricks. We don't have an easy way to do that right now because all we're doing is just stripes basically, and we don't have any specific way to control those blocks unless we do a lot of manual tweaks for this, and we don't want to do that. The solution to get this to work is very cumbersome, and we're going to build a solution that will allow us to use any geometry from Houdini VOPS and then project that into the height field and start with that. So let me explain this concept. I'm gonna create, let me copy the height field, and this is our height field. Let's create a grid and give it the same size. Okay. And with this grid, I'm going to select half of the points and move them up. And let me select these points and move them in. Cool. And then what we can do is we can use a height field project node, connect the height field and then the geometry that we need. Now if we take a look, we can see the height field is matching that. So it basically does a ray casting and figures out the height from the input geometry and use that. And this is great because we can use this technique to initialize the height that we need. And I'm going to delete this, and let's set the grid size to 10 by 10. I think this is good. And what I'd like to do is I'd like to change the height of each of these primitives. So first of all, we're going to put down a facet node to make each one of them unique. So each one now is unique surface, and we can move it independently. And I'm going to put down a point VOP. And inside this point VOP, we're going to vary the height. So let's dive inside. And what we can use, if we take a look at the primitive numbers, sorry, this one, you can see each one of these guys have a unique number, and we can read that in. So let's read the primitive number and generate a random value based on that. Connect the position and say we want the result to be, okay, 1D float, that's fine. Let's connect that to the color. Let's make sure we're looking at the node. And now we're getting color variation per primitive. And this is great because we can use this information to vary the height. So set vector component because I just want to modify the height. And set the Y and connect this. And now we should see height variation. Now the value is not, the height is not enough, so we want to increase that. I'm going to put down a multiply and promote this guy. So we have a slider at the top, and you can see now we're varying the height. And if we look at the node, boom, we have height variation in the height field. And this is a great way to start doing the processing. Now one small thing I'd like to do is I'd like to make the gap a little bit bigger between the primitives, between the faces. So I'm going to put down a primitive node and just scale the size a little bit, something like that, just a tiny gap. And now we have a gap between each one of them, so it's much easier to start working with this. Cool. So now that we have that, we can start working and make this a little bit more interesting. I think the height is too much, so let's stay with 20 for now. Yeah, let's stay with 20. And the first thing I'd like to do, let's increase this. Let's lower the resolution. When I say increase, I mean increase the resolution, which means lowering this value. So now we have more details. But you can see even if we go higher, it's going to get, it's not going to give us perfect edges. This is really high. Yeah, it's not going to give us perfect edges. You can see it there. So what I'd like to do is I'd like to blur this result a little bit. So blur, height field, blur, and we can do just one pixel, one voxel, two voxels, and now we have much nicer edges. And the next thing I want to do is I want to break these up. I want to break these lines. So we can put down a height field distort node. And now we're breaking those lines. Now let's tweak this a little bit more. And let's increase this to 20. I have previous values, so I'm trying to get something close to them. Cool, something like that. And let's add some noise now. And this time, I want to use the similar noise that we've used previously, which is the simplex. Where is the simplex? With the hybrid terrain, and I want to set the mode to subtract. And with this, we can get some details removed from the volume. So something like that. You can see these nice curvature and nice cavities going on. And I'm going to increase this a little bit more. Sorry, lower it, maybe 60. And maybe increase this. Okay, we'll leave it at that for now. And let's add a little bit of customized noise. So what I'd like to do is I'd like to create a mask to separate the edges in between these guys. And I'm going to put down a height field mask by feature. And this time we want to analyze the slope of the mesh. So in this case, let's try and increase this. And there. We have the data that we need to add the breakup to. Cool, so let's add a height field noise. Let's connect that and use this as the mask. And I'm going to change this to be a subtractive mode. And I'm going to change this to terrain as well. Just to get more variation. I don't have anything specific at the moment. Okay, something like that. And let's see. Let's add. Now, right now we're just isolating a very specific narrow area from the cracks, and I'd like to expand that. So what I'm going to do is I'm going to copy this. I'm going to use the same input but expand this so I can affect a bigger area. And there is a node for that. We can use a mask expand, height field mask expand, which basically grows any mask we have. So this is the result. And for the expansion, let's set it to 2, and maybe let's blur it a bit. And now it's too much, something. Okay, cool. And now let's go a little bit more aggressive with the lines. So let's try height field noise again. Cool. So let's try Yeah, I just want to make more variation, and I'm looking into getting these kind of details. Let's try different noise. That's too much, so let's turn off centered and see what we get. It's pushing everything up. Cool. So let's go negative -6. Cool. Yeah, I like this, and we can add a little bit of distortion. I think this mask is very sharp, so let's add distortion. Change this to mask. It's too much. Something like that. Cool. So now we have more distortion happening there. I think this is too much, so let me reduce it down. Yeah, something like that. And now we have very, very interesting edges with these bricks, with these pavement. Now I think the distortion that we added at the beginning is too high, so I'm gonna lower that to 10. Yeah, something like that, so we don't change the ground too much. And we're starting to get something really interesting now. Cool. So the next thing I wanted to add is I want to add another layer of details to this. So what I'm going to do is I'm going to create another noise, and I'm going to set the fractal to standard FBM and leave this at that value. And instead of having an add mode, I want to change it to a minimum. And you can see what kind of details we're getting now. And let's change the values here. Cool. This is what I'm looking for. I wanted to make a sharp holes in these guys, but I don't want to push them. Let's see, I don't want to push them in. I want to push them out. So let's say -60. That's too much. You can see already. Let me copy this, and this is a happy accident, but I really like this result already. I think it looks really, really cool. And these kind of cracks here, where you get a wide crack and then it disappears, nicely blends into the existing rock, is really hard to create in many other programs, and even in Houdini as well, except with using this tool. So let's try. Try this. And I'm trying to offset this, but so far it's not working as I had hoped for. So let me do something. Let me add a transform, height field transform, and push the height field and see what we get. Cool. Yeah. So because of the region this guy works in, we were not getting the proper range affecting the mesh. So now by shifting it up and down, we can control that, which is really cool. And we can remove volumes nicely. Cool. So I wanted to do that, and then I wanted to also add extra volume to this. So I'm going to copy this node, and let's try max this time. Okay. And let's turn off centered. Yeah, it's too much for the max is not working in this case. So what I'm going to do is I'm going to leave it at add. Okay, and I'm going to create a noise, height field mask noise, and let's take this and create our noise. So let's leave it at 1. Something like that, and let's connect this guy and see what we get. Now we should be affecting the mesh only through that noise. Cool. I'm just trying different combinations to see which one gives me the correct value that I need. I'm gonna change it to add because I think that's the one that will work, and I'm going to reduce this to 20. It's not doing exactly what I want, but I will show you guys the file that I have for this effect. I can show you guys now. This is the idea that I was trying to go for. I'm not sure why this is not giving me the same result, but let's try one more time. Let's try with the minimum. Okay, cool, and let's push this. So it's not doing anything. Let's try. Okay, cool. Yes, this is exactly what I wanted. But instead of this direction, I wanted it to push out. So let's try -100. That's not doing it. So the only way to get around this is using the transform. So let's do that. And let's look at this. Okay, now the noise is gone. Okay, fine. We'll go with this. I'll give you guys the file, but I was trying to get those two details to come out. But this is cool as well. Maybe too much, so let's reduce this to 100. Cool, something like that. And this technique can also be applied to any other tools, terrains or geometry that you're creating as well. If you want to subtract volume, this technique is very, very interesting. Cool. So the next thing I wanted to add is I wanted to mix between this terrain and basically remove all the details and make flat areas that we can use to add extra details on them or completely different details on them. So what I'm going to do is I'm going to create another height field noise, sorry. And I'm going to set the mode to minimum as well. And you can see already that it's doing the effect that we want. We're removing details. You can see here they're being removed completely. So let's play with this. Very cool. And let's play with this value. Cool. I'm going to go a bit extreme on this, and I'll explain why in a second. So something like that. I wanted to make a big area where it's completely different. And now we can do a height field clip and we'll get the effect that we wanted. So min, compute range, and let's start playing with the min. Cool. Let's go up. And let's clear the display. So height field mask clear or layer clear, and boom, this is the effect that I wanted. I wanted that sharp transition, and let's play with this even more. So let's say 45. Maybe even more. 25. Yep. And let's remove the softness. Cool. So this is the main this is the idea that I was looking for. And because we're losing some details here, it's too much clipping. And what I'm going to do is here I'm going to, maybe let's just tweak the clipping so it doesn't go this far. Yeah, something like that. And this is primarily the effect I was looking for. And now again, we can take this area and let's say mask by feature. And let's mask by height. Yeah, and the resolution is too high, so let's lower it a bit. So mask by feature, and let's get the range that we want. So there, cool. And let's do a transform, and I'll explain why this in a second. So the height transform, I want to zero out the scale, and I want to make sure that the level this at, so I'm gonna control click this to have it still in the viewport, and I'm going to offset this so the minimum level is that. Cool. And now I'm going to treat this as a completely different surface. So I'm going to put down another noise. And this time I want to create some kind of rocks, small pebbles. So I'm going to change it to F2 minus F1. And I'm going to turn on center noise to try and keep the range of the noise in the same level of this, but we can always offset it as well. So let me reduce this guy even more. Cool, so let's try 20. Nice. And let's add more noise to them. So the FBM is really good with this. Let's try. Yeah, let's try this, and then I'm gonna use the distortion because I know it's going to add some interesting details to this. Cool, something like that. And now we can do a layer, height field layer, take the original one, the second one, and then the mask, and boom, we're mixing the two nicely using with the rocks now. And this is really cool. Let's do one more thing here. The distortion, I want to apply it to the whole mesh as well, to all the details, but I'm not going to use this node. I want to create a distort, height field distort. And I want to use this. So let's reduce this guy. Something like that. 4. Cool. And we can also add another noise to break this even further. So let's turn off center noise and make sure it's set to add. And I want to add more variation, so let's change it to standard FBM. And I want this to be 20 maybe. Yeah, something like that. Let's see what we get. Now you see the height is too much for this, so let's turn on center noise. Cool. Now it didn't change the height field too much. It didn't change the height field too much for us. Something like that. I just want to add a little bit of variation to the height. Okay, cool. So now we have very nice mixture between these two. Now the last thing I want to add is I want to add a little bit more details to these surfaces. So what I'm going to do is I'm going to create a height field noise, height field mask by feature, and I'm going to use the slope. Let's see if it gives us what we want. Not the slope. Yeah, we can use the slope, but it will affect. So let's combine these two. Let's say with height, anything that is in this region. Sorry, anything that is in the upper level. Cool. And let's make sure. Yeah, something like this. I really like this mask, and we can definitely use it to create something interesting. Now let's do one more noise node with that mask, and let's try to lower the value. I just wanted a little bit of breakups here, so 20, maybe more. Something like that. And now we have more variation on these areas. Now in the next video, I'd like to show you guys how to create more interesting cracks and hopefully add a little bit more details to the original geometry. Let's continue and add a little bit more details to this. And what I'd like to do is add cracks to all this, to the entire height field. And the easiest way to create these crack lines is using the height field pattern node. And the pattern that we're interested in is called cells. And instead of height, I'm gonna type in mask, so it creates a mask. You can see already we have something very interesting. And I'm gonna reduce this, reduce the width, increase the jitter, not so much. And let's see, something like that. And let's add some distortion to it. And we have to be careful with the distortion. Maybe that's a fine distortion. And then let's add another distort node and add a bigger distortion. So mask. And let's see, let's increase this. Yeah, something like that. Something like that. And let's lower the width, the thickness of the lines. And now because it's too thick, it's starting to disappear because of the resolution of the grid. And what I'd like to do as well, instead of having it uniform, I'd like to multiply it by another noise. So I'm going to create another mask noise. And let's generate it on this guy. Sorry, on the original mesh. And let's multiply the two. So height field layer. And let's multiply both of them, and I'm only interested in masks. So let's try all of them. Set the value to 1. It's hard to see because it's multiplying everything. So let's do it all at once, and then we can mix both of them. So I'm gonna put down a height field node, a noise, height field noise, connect it to the original geometry that doesn't have the original volume, that doesn't have any cracks. I'm gonna connect the cracks now, and let's make sure that the value of the cracks is reasonable. And to do that, we're going to use we'll do it in the next video. For now, we'll do it when we learn how to process these fields using wrangles and volume VOP. But for now, I'm going to tweak the values by hand. So I'm going to set it to 1. And the cool thing about this, because the noise goes from -1 to 1, it will create both. It will push out the geometry and push in certain areas, and this is based on the noise type. So for example, this sparse give us a value that goes from -1 to 1, and so we can use that. Let's change it to simplex simplex only give us it's giving us in both areas. Let's try -1. Yeah, so if we turn off the center noise and then set the value to a negative value, we get the push in that we need. And actually we didn't need a clamp, so it's all good. We just needed to tweak the cracks. You can see now we have some very interesting details in there. Now the cool thing is we can take this original geometry and let's expand this, mask expand. Okay, maybe 2, and let's blur it. We've done this, but I want to show you guys the interesting details that we can get from this. So mask blur 2. And it's not. Yeah, we definitely need to clamp the values, but for now we don't know how to do that, so we're gonna use this as it is. It's definitely blurring the data, but because the values are too high, we're not seeing the softness. But it's fine. It's gonna work when we connect it to this. So I'm gonna connect the new mask, and boom, we have some nice soft. See that soft blend in the cracks? We didn't have, not like before. Before was super sharp, and now with this nice transition, we can also play with the noise frequency. And obviously you guys know this now. Cool. So this is what I wanted, and we can obviously control all this and combine it with the original. So what I wanted to use this noise for is to decide where the cracks are going to happen and where not. And because it was tricky to multiply the masks and everything, I decided to create this, and then we can easily blend between the two. So I'm going to put down a layer node, and then this is the original result, and this is the mask. And now you can see we're blending between both of them. And we're only getting cracks where we have that noise mask. And the cool thing about this is we can, where is it? We can take this mesh, this detail here, and we can export this as a map by itself. And we can also export this guy and create another information where we only have the cracks multiplied by this, and use that in the shader to drive various other things. And this is pretty much the final result that I wanted to get to. We can start adding, of course, a lot more details using the mask by feature, and this is going to start creating some really cool stuff. So for example, let's isolate that, and let's create a noise. And this noise, I'm gonna make something different. So I'm going to change it to F2 minus F1. Let's turn off center, and let's reduce the size so that we can see the actual pebbles or rocks. And you can see them here. And let's blur this mask just a tiny bit. That's too much, so let's say 3, maybe 4. And we definitely need a very high resolution for this, so I'm gonna go a bit high with this, so let's say 0.3. I want to show you guys all the insane details that we can get in here, and you can see now it's taking, let's see, 10 seconds. Shouldn't take too long. Hopefully before 30 seconds we are done. Yep. And now it's displaying the geometry. Cool. So it's actually really fast if you look at all the nodes and what we're doing. And let's take a look at the geometry created. See all the insane details here. Obviously we're seeing some more fine noise that we didn't see before, and we need this resolution to tweak those values. And this part is really cool. Now let me reduce this back to 1. And let's lower this to 10. And what I'd like to do for this scene, I want to put an erode and run a quick erosion simulation on this. Let me make sure. Okay, let's hit play. And let's let it run for a few frames, and you can see already that it's creating some really cool details. Now obviously it's blurring a lot of stuff that we've created, but I think the end result is really cool. And we can let me show you this. Okay, let's stop here and let's see if the visualizer will give us something. Yeah, definitely there is an issue with the viewport. It should display this without any issues. Height field visualize. Yeah, it needed some refreshing, and now this is displaying correctly. Cool, so you can see we have a lot of interesting details generated. Obviously we need to increase the resolution to get super fine details, and I don't want to waste the time. And what I'd like to do is, so let's say we're happy with this result, and let's turn off the visualize. We're happy with this result, but we don't want to change everything. So for example, I really like how the rocks are forming here. It looks really natural, but I think we're losing too much details on the bricks. So what I'm going to do is put down a mask by feature node, and I'm going to use the height, mask by height, and let's go down. Something like that. It's definitely a bit hard, so but we can go and use the original noise that we had, and I'm going to put down a height field layer node, and this is the original one, this is the eroded one, and use this mask. And now we're only mixing, see, we're only changing this area here with the erosion, and it looks really natural with all the rocks and everything. And I think that's pretty much it for this lesson. Hope you guys like it. In the next video we're going to learn a few more things about how to process volume fields and height fields manually. And actually I remembered now, I wanted to show you guys a different thing here. So with this data, we have the primitives information. We have each primitive is unique, and what I'd like to do is I'm going to create another primitive node, and I want to scale it to 0. Scale each primitive to 0, and you can see by doing that we have the centroid of each primitive. Okay, so we can use that information to transform the points, and we can. It's actually really easy to do that because we have 4 points here and 4 points here. So I'm gonna put down a point VOP. I'm gonna connect the first one, connect the second one, and I want to rotate each of these primitives based on that point, based on the centroid. And I'm going to put down a point import attribute, import point attribute, and this guy will can read a second input, a different input. Sorry, I don't need to connect this, so we just need a second input, and then the point number is actually the same point number because we didn't change that. And if I connect the result now, you will see all the point snaps. Okay, and if we do a mix and blend between the current point and the fused points, we can transform them. Cool. So let's put down a transform matrix node, and this is our position. Okay, the pivot is going to be this. I want to rotate these points based on the point here. And let's connect this. And let's try. Boom. Now we're rotating each primitive based on that. And how cool is that? We can do this then. We can do a random based on the primitive number. And what we want a, let's say, 3D vector. And let's connect that to the rotation. You can see there is a slight change. So I'm going to put down a multiply by a constant, and let's increase this. You can see we're rotating them, but I don't want to rotate them along this axis, which I believe is the y-axis. Yeah, so I don't want any rotation on that axis. So what I'm going to do is I'm going to put down a vector to float, or actually let's say a set vector component, and we'll want to zero out the second value. So this, it's 0 because we don't have an input. You can see how they're deforming back and forth. So let's try something reasonable. And I don't like the randomization that I'm getting, so let's add a value here, just add constant, and this will change the seed. Okay. Yeah, I do like to have, you know, variation in both directions, but I don't want to overcomplicate this. So let's keep it at that, and let's take a look at the height field. Cool. So now we have rotation variation between the blocks, and let me make sure that this is set to a reasonable number. It is. And let's take a look at this, and I think we're done for this video. Cool. So now we have the rotation, the original one, which is something really hard to do, to control per block with the height field. And I think that's pretty much it. Hopefully you guys like this. I do think that this result, I definitely need to stop, but I do think that this result has a lot of cool, interesting details to it that we can generate using, for example, if we add a little bit of clip here, maybe something like that, and then at the top as well. I think there is a lot of detail, so let's clip in the negative side, and let's make this sharper, and let's put down a clear height field mask clear, and boom, we have something really interesting still, and it doesn't have a lot of variation, but there is a lot of cool details. So now we're going to take a deeper look at the terrain tools and how it works. This section here is a little bit more advanced than the previous stuff we did, and after understanding how the terrain tools work, we're going to dive deeper and see how it is built, how it is made of. And by doing that, we're going to be able to create a lot of new custom things and hopefully make better use of Houdini volume VOPS to process this. And before we get started, we need a little bit of fundamentals about the volume and how the terrain tools works in Houdini. And so if we have a grid with points, we can use a point VOP, and we can take these points and process them, let's say add noise, or to change the position of the points or change the colors. We can create new attributes. We can do anything. We just have P position, a P for the position, and we change that. Now with volumes, it's a little bit different. Let me try and draw a unsuccessful cube. Okay, we have our cube here, and this represents the domain for the volume. And let's say we have a sphere volume, and this doesn't matter what the volume type is, if it's a VDB volume or a native Houdini volume, the theory is the same. So let's say we have a sphere inside, and we want to change the value of the density, which is the main field that exists. An empty volume doesn't have fields. And in order for us to visualize the data, we have to create a field. And think of a field as an attribute. A volume field is like an attribute in points. And we have two types. We have either a float, a scalar field, or a vector. I'm going to try, okay, a float or a vector field. Same applies to points. We have either a float attribute or a vector attribute and or an integer, but that's basically a float, just it's an int. So the way we see data in Houdini, the volume, we generally look at the density field, and then if we have other information, we can take that density field and colorize it with other attributes to visualize them. And the density, let's say we have a sphere. What happens in this domain is that all the voxels that are in this space will get a value of 1 for the density. Everything else will get a value of 0. Now the data is present only here. Only specific voxels have a value of 1. And what we can do is we can change that. We can change the value. So let's say this guy is 0. We can change the value of that and add another value to it. And we'll see data starting to show up here. And this guy, this information here, will be always there, but we can change its value between 0 and 1 or any range we want. So we can change the density, the opacity of the object. But let's say we want to deform, we want to push this sphere 5 units to the x. Okay? Well, with points, we can easily do that. But with volume, we cannot. We can only change what is already there. We can only change the values per voxels. If we want this voxel to, say, get a new value from here, and basically that's how we're going to do the offset, we need to use something else. We need to use something called volume sample. And let me type here, volume sample. And what this node does, I'm going to refer to the domain as a square from now on because this is very bad. And let's say these are our voxels in 2D space. And we have data here in these voxels. In order for us to tell this voxel here, go sample your value from here, we need to take the point position of that voxel, add 1 unit to it, and then tell it to sample from here. So this position, this voxel can sample from a different location. And this is how we can properly this is how we can properly disturb a density field in Houdini. If we want to change the silhouette, we can easily do that. Now let me show how this works in action. I'm going to create a sphere. And again, don't worry about all these tools. We're just trying to understand a little bit about volumes. We're going to come back to this once we start doing proper 3D volume, but I need to explain this section in order for us to move forward with the terrain tools. So I'm going to create a volume. So if that's our sphere. Okay. And I'm going to, I want to see if I press W, actually I can change this to, yeah. So this is the sphere and that's our domain. Okay. If I want to change the density, I can use a volume VOP. And this is what we use to operate on the voxels at the voxel level. So I'm going to dive inside and we have something very, very similar to the point VOP. We have density coming and density going. And if I disconnect that, nothing happens because the data is just keep going, keeps going through, and we need to change that. So I'm gonna create a noise and use P for the noise. So we generate a noise unique per voxel, and this position will return the position of the voxel each time. So it will loop through, and I'm gonna use that result and simply multiply the density. You can see we're changing that, but we're not deforming, we're not changing any other we're not changing anything else outside this because that's where the data lives. Okay, we cannot move this 5 units away. And so how we do the transformation, how we tell voxel to sample, well, we use a volume sample node, and with this we simply connect the output and tell it to read from the first input. That's what we want to sample. The primitive, we can choose the primitive number or the primitive name. Now the primitive number is always this list here. It starts from 0 and then as it goes through basically increments by 1. So we know that density is number 1. You can see here it's asking for the sample position. All we have to do is connect P. Okay? And if I turn this off, you can see how the entire volume has data. Now let me change something because VDB has a feature and I don't want that feature. So let me put down an ISO surface, and this node creates a volume, a Houdini volume for the given data. And if we take a look now, you can see that we filled all the voxels with a value of 1. Now let me create a constant to show that. Okay, we filled this entire domain with we've given all the voxels a number of 1. Okay, now let's plug it back to get back our sphere, and that's where the density is, and let's use the volume sample to offset this. Now I'm going to connect the P as it is. The primitive number is number 0, and let's connect that. Make sure we give it a name. I'd like to give it a name, so our data has a name. And now what we can do is we can start adding noise to this. Okay, so let's add the noise to P and make sure it's a 3D noise. And now it's actually shifting the voxels. So what's happening is each voxel is sampling from a different position, and the new position is the position plus this offset. Okay, I can lower this. You can see it goes back all the way to 0. Now if we want to shift it, move it along a specific axis, we can just take P and let's say add set component, set vector component, and I'm going to set, let's say, the Z axis, so the third one, and connect this guy. So now the Z is zeroed out. We don't have the Z anymore, but I want to offset that. So I'm going to add a vector to float to get the Z by itself and add a constant to the Z. And let's connect that. So now if we scroll this, you can see we're moving the sphere through the volume. And that's basically how we shift data in the domain, because we're not changing the density, we're not changing the existing value, we're offsetting where that voxel may get its value from. So this voxel now is sampling this voxel is sampling its value from here. This voxel is sampling its value from here, whatever the offset we're putting. So now if we connect back our offset, we get the, let me connect this. We can change the density, we can tell the volume to sample from a different place. Cool. So how is this relevant to the stuff we're doing? Well, let's go back to the drawing board. And let me move. And all what's happening with the pardon me, with the terrain tools, we have our grid, and all there is one level of voxels. There is no depth, there is no x, there is no y for the voxels. It's just one level, and we're operating on a 2D volume. Okay, so we don't have a height. But then how is Houdini displaying the height? How is it figuring out the height? Well, it's actually a very clever thing that side effects did. The 2D volume has a value, knows the position of each of these voxels. Okay, and that's all we need. We just need an XY information, and then the information that tells it how high the point is, or how high the display should be of that point, is using the density field. And in the terrain tool, the density field is called height. Okay, so if we create a gradient, a density of a gradient that starts 1 and goes all the way up to 0, the height field will display this as 1 here in the viewport all the way to 0. And if we look at the terrain tool, there is the display here is actually just OpenGL stuff. So this guy, if we take a look at the result here, this is just an OpenGL display. If I hit the preview, there is nothing. It's just OpenGL. And the thing that drives the height is the density. But the density in the field is simply called height. And then there is all these attributes that tells Houdini that it needs to display this field specifically. But this guy is just the volume field. Cool. So now that we learned this, well, let's go back and let's see what we have. Let's put down a height field noise. Cool. So this is the height field, and we can start playing with it. If we middle click, you can see it's just height and mask. Actually, we don't need the mask at this point. I can delete it just to prove that to you guys. So no more mask, it's just the height. So one field, and we're getting the display of this. This is a great node. This is a very cool node. But I don't want just this. I want to have access to all the Houdini volume VOPS. I don't want to be limited to this unified noise pattern node. And then the other thing we have is the pattern, which is this. This is great, but again, I don't want to be limited to that. I don't want to stay at this level. Let's say, for example, I put down a Worley noise like this, but I want to change this. I want to change the size of the Worley of these guys to have a specific size per area. Let's say I want to change the size here to be something else here and something else here. I don't have any of that control. So in the next video, we're going to start creating our own height field modifiers using volume VOPS. And this is where the true power comes in with working with terrain tools. And we're going to learn how the height field noise node works. We're going to learn about the clip node, the curl, the distort node, and how all of it is working together. And then once we go a level deeper, we're going to be able to do a lot more stuff than just using the terrain tool noise and stuff. So let's get started with that. So now we're going to start creating our own modifiers to deform the terrain and create interesting patterns. And the first thing I'm going to do is create a height field noise. I want to show you guys something. And this node is actually an OTL. This is a group of node, a subnet. And if I double click, it's going to take me inside this. And if you look at this node here, it's saying a volume VOP, and it has this interesting tab for the volume binding set height and with the height and density being remapped, and then a terrain layer node set to add. Cool. So which means that this node is nothing more than a volume VOP. So let's delete that. Let's create a volume VOP. And we're not going to be changing the voxels value. We're not going to be changing voxels and tell them sample from a different area. We saw that we just need to change the density for Houdini to start moving it, displaying it like a terrain. So let's dive inside. And now we have the density. So let's create a noise here. And it's a 1D noise. And let's multiply this density and see what happens. Well, unfortunately nothing is happening. So what's going on? Well, the reason nothing is happening, actually I'm going to resize this to 10, and because I noticed that the noise value that we're going to be creating works better, gets really sensitive when it's at that scale, and I don't want to be scaling everything. So I'm going to change this to 10 by 10 and lower the the grid spacing to 0.01, which should give me the same voxels. Okay, so 1000. So the reason this is not working is because the field here is called height, and then if we dive inside, this guy says density. So what we need to do is we need to do that mapping. If we go under volume binding, it says auto bind by name, which is ticked on by default, and that means if you export an attribute, it's going to try and map it to an existing one in the geometry. So I'm going to turn that off, and then I'm going to click this one and say I want to map the primitive name of height to density. And let me make sure that I'm doing the right thing. It should be, that's the height to density. Yes. Okay, let's go inside and let's try and increase the value. Interesting. Let's try and connect this. Okay. Well, sorry, we didn't have to multiply this because the value of the density was 0. So if it's flat, if it's at the origin, this means 0 to Houdini. Okay, and if actually I put down a constant and connect this, you will see it doesn't change. And as I start moving it, it's gonna go up. And this is just Houdini and side effects doing an awesome job of being able to display this the 2D volume this way. And so if we just connect the noise, now we should get exactly what the terrain tool does. Okay. Oh, sorry, what happened? Cool, so now we have the noise working. Awesome. And now everything is open to us. Now everything becomes accessible. And all the height field noise provides for us is the unified noise. Well, we have it there. I'm not going to worry too much about that. I'm more interested in generating my own noise, and especially the fact that the height field doesn't generate a seed. This is a limitation of the unified noise. I want to be able to generate a seed, and I will show you why. Now let's create our awesome Worley noise, and this is the position. And let's take a look. Let's connect distance. Cool. So we have that. Let's connect this. We have something else not so interesting. This doesn't generate anything, and the reason for that is because the scatter is set to 2 points. Let's change it to 4 points, and now these two guys have more data on them. And let's take a look at the seed. Well, the seed is a random value. So what we can do is we connect a random, which we've done, and boom, now we're talking. Now we have a height variation based on the seed, which is really awesome. But the only downside here is we cannot blur the edges because we have to process that afterward, but I'm not going to worry too much about that. Now let's see how that pattern is created from the Worley. Well, it's created, if we look at the unified noise, it says F2 minus F1. Well, these are F1, F2, F3, F4. If I connect that now, boom, we get our result. And this is what we're used to see. Okay. Now let's take a look. The position of this guy starts from -5 and 5. So let's take a look. Let's take the which one? Let's take the x-axis and let's fit it between -5 and 5. -5 and 5. And let's connect this. Interesting. Now we're getting a linear value here. Okay, let's try this. Let's get this and do the same thing for the x and y. For the z-axis, sorry, and connect this. Cool, now we have that. Let's add both of them together. And now we have something like that. Well, the cool thing is now we know that we have a 0 to 1 mapping here. Okay, And this information is going to be really handy later when we are going to do something else, and we'll get there. But basically we have a 0 to 1 map now for this grid. Cool. So what I'm going to do is I'm going to connect this result, and now that we have a 0 to 1 range, okay, I'm going to create a vector out of that. So float to vector, and I'm going to create a vector that has basically three values, which is the same one, and I'm going to use that in the frequency. Now this guy has a frequency of 1. Let's try and plug that. Interesting. Now we're starting to create some very interesting effects. And if I change this to if I scale this or change it in any way, I can control the frequency using a ramp, which is awesome. Now let's try this. Let's do this. Let's put down an actual ramp. Let's go up. And we have to make sure that the ramp is being fit between 0 and 1, and then we can change it later if we want to. Now we have to make sure that that guy has a value, something like that, and then we can change this in any way we want, which is amazing. Now the result is obviously not very interesting at the moment because we still have to tweak a lot of things to get this to be interesting. But what if we do this? What if we do another Worley? Okay, and let's connect this guy to see, or actually let's not, I don't care about that result. I just need a simple Worley. I'm going to generate a random value from the seed, and let's connect this. Now what if we have a Worley of these blocks, just these guys, and I want to vary the value, the frequency based on each block. Let's do that. So we have a value that goes from 0 to 1, which is this random here, and I'm going to copy the fit, and let's create a vector. We don't have to, but we don't have to do this step, but I'm doing it just to make it clear for you guys. So this is the fit, and let's connect that to the frequency, and let's take a look at what we get. Awesome. Now we're getting something really interesting, and let's change the min and max between 0 and 1. Wow, this is really cool. So we can change the frequency of the input based on another input, and this is very powerful technique because we have so much flexibility on what we can do. And now all of a sudden we have no more limitation. There is nothing that prevents us from doing anything we want, and we can, let's say, we can play with all these values to control the min and max. Now this is with a Worley. Let's say we generate a noise, okay, based on this position. Now this noise is going to go between 0 and 1. So let's clip it. Let's say clamp, sorry. I want to clamp this between 0 and 1, and let's connect this to the fit here. Ooh, interesting. Now this is what we get, and let's lower the frequency and increase the amplitude maybe. Or actually, you know what, instead of the clamp, let's fit the noise from -1 to 1, so we capture the full range. And now we don't need the clip anymore, and let's lower this a bit, and let's make sure that this fit is between -1 and 1 as well. And it looks like everything is, sorry, this needs to be 1. Yeah. And you can see now how the difference between the blocks. I would like to increase this even more. So I'm gonna set this to -1. Yeah, it's hard to control it this way, but you get the idea, and hopefully you guys will be able to generate more interesting stuff with this. Cool. So let's say we have this. I'm gonna keep it. I like what I have. Okay. And let's leave that. That's fine. And now instead of using the current position, you know, I want to break these lines. Instead of using the current position, I'm going to add a noise to the position, like we did with the texture. So I'm going to change this to a 3D noise. And by just doing that, we have an amazing result. Let's increase this. And boom, we have some really, really cool stuff. Let me make a copy of this. I don't want to change the frequency just to show you, and to show you better the effect. So I don't want to disturb everything. And let's roughen this a bit. And let's try 1D maybe. Yeah, something like that. And the 1D doesn't change the height as much, but we have some limitation obviously. Now what I liked a lot about this idea is, you know, the blend in between these different material. There's a lot of interesting mixes that we're getting, and there is so many options. Now this guy, for example, the offset, let's do this. Let's create another noise. Let's create a turbulent noise. I'm gonna connect the position. Okay, and let's connect this guy to here, to the offset. Wow, look at that. We're creating some really interesting patterns, and the reason for that is because the reason for it giving this pattern is because the noise is not 3D, and if we do a 3D noise, then we will be able to offset the position. We can do something like that. And now we're creating some really interesting pattern. Now the height is, we can control that no problem, and we can simply multiply all this because it's just a density value. We can multiply this down, and we have, you know, less displacement happening. Cool. So let's do that soft clip that we were doing before, and it's actually a very simple thing to do. We just put down a soft clip node, hit tab, and the main disadvantage is we don't have the range. We don't have a known range, and the script has ways to analyze the range. Let's control this. Let's lower this. Okay, cool. So now we're clipping that data. We can also, this is a soft clip, but we can also add an actual clamp, and the clamp will have much harsher transition. So it'll be basically stripping the data out. Now the cool thing is we can take this, we can do a mix this with the original, and I want to restore a little bit of that original. So instead of 0.5, we can create our own transition back at the top. We're just adding density, and look at that. Isn't that cool? Okay, cool. So let's continue. What's next? Let me check something super quick. Now I'm going to, I've run into a pattern that I'd like to show you guys. So I'm going to create a noise flow node, and I'm going to use that for the frequency. it may not generate the same pattern. I'm gonna remove, let's see, it's actually connected to this guy, and boom, by just doing that you can see already we have something really interesting. And the cool thing is we're getting real-time feedback of this. We're not, and right now we're just offsetting the we're changing the frequency of this pattern. And let's offset it. Let's try 3D. 3D is not going to give us something very interesting. 1D was the one I used. And if we change this, we can create some very cool stuff. And with this noise, let's say I wanted to add this back. I wanted to add this with the result. And let me remove the clamp. I don't want any clamping. I want to see the values. Yep. And let's add that noise into the mix. Okay, I want that back added. I'm gonna multiply that by a constant and want just a little percentage of it. I don't want everything to be affected. Cool. Oh, we have that. Let's see what can we do. Let's lower the scale. Let's look at this. And these patterns are really complex. They're much more complex to do with, obviously, with the simple tools that comes with the terrain tool. Okay, cool. So let's leave it at that. Obviously, it's not something very interesting at the moment, but hopefully you guys get the idea. I want to change. And now happy accidents again. Let me copy this so you guys can check it. And I'm going to connect this here. Okay, cool. So the next thing I wanted to add is I want to create a mask attribute. Okay, and all we have to do is, let's say we have this noise pattern. Okay, we can simply bind export that and just give it a name of mask, and that's it. And now we should be able to visualize it. Let's make sure. Yeah, sometimes it does not visualize the mask for some reason, but let's make sure it has. Let's try it with a constant value. Let's say I want to export a constant value of 1. Okay, let's try the visualizer. Remove custom tinting. Yep. Let me create a new view. Yep. So the reason it did not work is because the auto bind by name was turned off, and I needed that. I needed to specify the mask. That's why it's not working. Now, if I dive inside, I can have. I can take a look at that noise pattern as a mask, or I can analyze anything from the data. And this is very powerful because what we can do, we can take this result, which is basically the height field, and you can see how it's displaying that from black and white. Now, because there is negative value, the mask is not going to be able to display that. And what I'm going to do is I'm going to fit this density because it represents the height. Think of it as the height. I'm going to set it to -1, -0.5, and the height, let's reduce it up until we hit that. Cool. So now we have that. Let's invert it. So now we have everything at the bottom. And the cool thing, we can do a ramp. We can plug in a ramp and use all the tools available in Houdini for this. And let me make sure. We need to give it a different name, otherwise it collides with the existing one. And now it's black and white. Okay. Why is that? It's because it's an RGBA, so it changed the signature. I need the vector to float and connect the vector float only. Okay, cool. So we have that, and let's isolate the bottom part. Okay, cool. Now we visualize that. Let's do something really cool. Let's add a, let's see. Let's do another Worley because I like these guys. And I'm gonna connect P. I'm gonna copy this because I want to change P as well here. So let's do that. And let's use this P with the Worley. And subtract. Now let's see what we get from subtracting different values. Let's try subtracting 1 from 3 and connect that to the displacement. Wow. Very, very cool stuff. Let's increase this. And let's multiply it by a constant so we can understand better what's happening. Okay. Very cool details. Now let's try 2 minus 1. Very cool details. Let's try F3. Sorry. That nothing happened. And make sure it's set to 4 points. Very cool details. See how we're getting some really interesting stuff. Let's add more distortion, and let me show you guys something. Now, if I change this to a smaller value, we can start creating those details we see in cliffs and stuff. So let's say an erosion would cause something like that to happen. Let's increase this to, it's too much. Change it back. Yeah, so let's keep it at that for now. We're getting too much distortion, so let's set it to 2. Okay, cool. And I want to add another one, so I'm gonna copy this, connect it, and this time I want to add a 3D noise. And for the frequency, I'm going to lower it to get even finer details. And look how much cool details we're getting now. And all of this being plugged into the Worley. Now the cool thing that this is what I wanted to do from the beginning. This is why I actually started doing all of this, I think. Let's generate a random number, and let's add this and see what we get. Awesome. Now we're getting some really interesting elevation changes with the random value. Let's multiply this so it doesn't change it too much. And I think the reason for this is because we're subtracting information from here with this guy. If we were to subtract F2 minus F1, we will be getting the displacement that matches them, because the other guys are not matching the seed. So now we are. Okay, so let's keep that there. Let's actually increase the resolution of these guys. And I honestly don't want to change the resolution because it's gonna start getting crazy. But let's try the offset. Man, this is really cool. Yeah, I need to stop. Okay, let's increase this, and I'm going to I'm gonna have this added as well because I really like it, and I'm gonna copy all this mess again, and I'm gonna turn off the offset, and I'm going to add these two together as well. So this with this, and let's multiply it down a bit. Okay. I really want to do something else, but I have to stop. I was thinking of using the height information from this noise to drive the intensity of this, but I'm not gonna do that. Or am I? Okay, let me do a quick test. Let me do a quick test, and if we get something, come on, I need to multiply. If we get something working, then we'll proceed with it. Otherwise, we'll continue as planned. Yep, it's working. So I simply use this result as it is because it's just black and white to directly multiply the second information, which is this guy. Okay, and I can use this height to control that. We can also flip it. We can do a fit range and say it's from 1 to 0. And let's control this back down. And now we're putting it on the other parts. We can also grab different sections from the field using this fit. Okay, but now seriously, let's stop. And the last part I want to add is the main thing we wanted. So this guy is I want to use that as a multiplier to mix these two. And remember, there was an add node that adds everything together. Where is it? So this is the information that we need, and I want to use this mask to blend in between these two guys. So I'm going to put down a mix, and the second input is going to be this guy. And the mask, see now it's been applied everywhere, and the mask is going to be the height of the original one. So this guy. And let me disable this so we don't have the mask being visualized. And look at that. Okay, now in the next video we're going to take this and add a little bit more processing to it. This video is getting too long, so we'll continue in the next one. So now we're going to continue adding more details to what we've created previously, and the next thing I want to show you guys and explain how to do is actually disturbing this data as it is. Okay, now if we look here, we have been generating noise based on the position, and that position we've been offsetting in many different ways to create this complex material. And what I'd like to do is create something like the distort node, which takes existing details and distort them. And that is different than doing this, because what we're going to be doing is shifting data. So instead of this voxel here sampling this value, we're going to shift that. And this is done using the volume sample. And I'm going to create a volume VOP node and turn off that auto binding because we need custom. So height equal to density, and let's just create the mask in case we wanted to do that as well. And we need to if we wanted to add any extra distortion to the mask as well. So if we dive inside and let's say we want to multiply the current density with a value. Okay, let's say constant value. We can do that. So we can change the density in any way we want, okay? Or the height. Let's try and say height from now on. And what we cannot do is we cannot change this detail. We cannot change where this guy is. But with the help of a volume sample node, we can do that. So I'm going to put down a volume sample, tell it to sample from the first input, and that data name, the data name is height. Connect the P position and connect this guy. And now we should see no changes. But if we add noise, if we generate noise and sorry about that, and add it to the position, let's add the 3D noise, we can start disturbing the field. Okay, and it's a 3D noise. So yeah, it's change. The reason it's changing on multiple axes, you can see it's changing the height as well, is because it's not just pushing vectors in the X and Y, it's also changing the lookup along the the Y axis. So what we can do to fix that is we can remove the Y axis of the P from being deformed, from being changed. So we can do a vector to float. Actually, don't need that. So from here, we can do a vector to float, and then from this section, from the deformed section, we can do a vector to float as well, and just take the X and Z from here, and the Y leave it the same. So vector to float, float to vector, and I need the Y from here, and the X and Z from these guys. And let's connect that, and now we should see that we are only changing along the X and Z axis. And this is similar to the distort node. But what we can do is much more than the distort, because we have access to everything now we need. And this is one example. So let's increase the resolution a bit. Something like that. And let's try add a Worley node. So let's do a Worley. And let's add it, subtract the value of these two guys, F2 minus F1, and add that, and let's connect the P. And boom, we're getting something very, very interesting, because we're pushing the position along the X and Z axis using this pattern, which is very interesting. But the cool thing, we can also keep adding on this. So we can add another noise. Let's go back. Hide. We can add another noise to deform the position that goes into the P of the Worley. I'm hoping that you guys understand what I'm saying sometimes if I skip the details, because it gets a little bit intense when I think and talk and work. Okay, let's try. Cool. So the last thing, I want to reduce this, so multiply by a constant, and let's lower this. Something like that. Okay, let's continue. Now that we have this, I also like to generate some masks, and these masks can be generated using the noise that we've created here, or we can analyze and do any kinds of processing. So let's say I wanted to create, I have, for example, something here and I want to soften the data, or I have an object here that I want to soften any displacement close to that area. So what I'm going to do is create an add and add a point. And if I hit enter, you can see I get the thing to control the position, and I'm going to zero out the height because I don't need that, and I'm going to, let's say, use this one. No, let's create a new one. So let's copy this guy because it has the binding set. I'm going to delete all this, and what I'm going to do is I'm going to create a vector, and I'm going to subtract the position, the current position of the voxel from that new position, from the point that we've defined, which is this guy. So I'm going to copy this, and I expose the second input. So let's make sure that's a 3D float, a 3 float, and let's paste relative reference, and let's compute the length of this, because we're taking each point and subtracting it, so it will give us a vector that is needed to move this point to that point. And if we compute the length of that, we'll get a gradient. And let's fit the range of that gradient of the ramp. And then let's do this. Let's set a constant, and if we set this constant to 1, we'll set everything to 0. And I want to mix the current density with the 0 using this result. And let's connect that and see what we get. Ooh, nice. Now we're getting something interesting. And with this fit, let's create a ramp. And let's expose the min and max because we need those to control them. And that's cool. Yep, everything looks correct. And now if we take this point, now we're masking details that are close to that point. And we can control the region using the min, using this ramp. So it can change the edges to have something like that. And now, right now it's affecting everything, and I want the inverse. So I want to make some kind of craters based on that. So let's say you have a set, for example, and you need the terrain to get to a 0 level and nicely blend into everything. We can use that. Now what I'm going to do is, I don't like how this is super sharp. I don't like how this is crisp, you know. I want to deform that. So this is actually really easy. And instead of just subtracting from the current P, I'm going to generate the noise and add that noise to this guy. And instead of subtracting, let's do it the correct order. Let's add that to 3D noise, and let's subtract that. And boom, by just doing that, we are disturbing the mask there, and we can create lakes, we can create anything we want, and we have the position to control that. And let's actually move this point. Where is it? This guy. And you can see as it moves. And let's maybe make one here. Okay, yeah, let's just make one here. I want to add another thing. So with this mask, I don't want to process anything here. I want to export it as a mask. So I'm gonna do a bind export, take a vector to float, and call this mask, and we should have our data in there. Cool. So the next thing I want to add is add a noise to all this, and because the noise is not centered, yeah, it's going to be hard. Okay, something like that. And because the noise is not centered to the because the noise is affecting everything, I want to use the mask, so I'm going to connect the second input, and now we have the mask. But I don't want this. I want the Worley noise, and let's move this up. Yeah, it doesn't have. Okay, let's turn off the hybrid thing. Let's increase the element size. Sorry, lower. I want to make rocks. And see, I'm using the actual height field node because I want to show you guys how you can mix and match between the two. So now we have very small rocks. Set this to 0.1 in there, and let's add the FBM again. So I want to add that to distort everything, and I want to clear the mask. So clear layer clear, and clear the mask, and now we're back. And so all of this is now procedural, and we can do anything. We can take this guy and this point, and let's do it again. Let's connect it again, and this time I don't want to clear this area, and this is the new point, so I'm going to copy the second input, paste relative reference, and now we have a second input. And let's move this guy here, and now we can do whatever we want with this information. What else can I show you guys? Let's see. Well, we can try something. So I'm gonna dive inside, and we have the mask and everything. So I'm going to generate a new noise, and this time I'm gonna go for the, which one? Let's try this flow noise. We've never used it, so let's try a flow noise and see what we get. And this doesn't have a lot of details. Sorry. Let's try with the AA flow noise. This guy. Okay, this is cool. Let's leave it at 1, and let's try using the feature of the flow to advect a little bit. See how it's advecting some of the flow details, and it's creating some really cool details. This is something I showed you guys with the unified noise, where it was pushing the details and advecting them this way. This is basically how it is achieved. And let's increase the frequency. And what I want to do is I want to push this to negative. So I wanted to push that detail in, and I want to mix between that and not 0, this guy, using that mask. So now we're pushing the details in, and actually to move everything down we can just subtract a value, subtract constant if I'm not wrong. So if we subtract a value, we can push it in and out nicely. Now let's do one last thing. I'm going to do that power. See how those edges are not blend in nicely. Well, it's too soft. I want to make it a bit sharper. So I'm going to put down this power node, and boom. Well, obviously it changed a lot of stuff, but that's how we can sharpen it. We have to tweak it a little bit more, but now we get some completely different area with very unique material in there. And actually let's do this. And remember, all of this is non-destructive, so everything is procedural here, and we can mix all kinds of interesting material. Now, one last thing, we can use all the amazing tools that we have with the height field. Those are all still valid, but I want to increase the resolution now and try something. Okay, let's see how much resolution we have. Hey, let's go a little bit more. Okay, cool. It's done cooking, and take a look at that. That's how much details we have, and it's running live. All this is being generated on the fly using pretty much custom node, and look at that. Very cool. So let's run that erode node. It's going to be a little bit slow, but I just want to run it for a few frames. And based on the grid scale, right now I've reduced it too much. based on that, the erosion speed and how much it affects the scene varies. So we have to tweak a few more things to tell it basically that this is a huge scene or a small scene or something like that. We have to play with these values, which I need to spend time, but hopefully you guys can have a little bit more time to play with this and test it. So this is what's happening so far. It's too small, so let's see if that height field transform node can scale everything. Yeah, it does. And let's make sure we have a low resolution. So I'm going to multiply this by 20. And I do this technique because I know that this is my default value and this is my extension. So if I wanted to come back to it later, I can easily do that. So let's scale the grid back. And how much are we? 100. Let's scale by 100 units. So now we're back to normal. And the resolution hasn't changed. So let's go and set this to 1. And now we should be able to, the erode options should work nicely with the scene scale that we have. It's going 3 frames. There's definitely a lot of changes happening. And this is a very high res mesh. It's, imagine working on a 9 million points and doing a sim on those where everything needs to be connected together. Okay. Let's wait one more frame. Cool. So see, frame 8. Oh, I see. Now because we scaled it up, I had it to scale the, sorry about that. So let me change this to something reasonable. I'm gonna set this to 3 so it's faster, and the height, we need to also increase the scale by 100 so it keeps the same detail. And now the height field erode should go much faster, but it's not going to generate the same amount of details. Cool, so let me clear the visualizer. Let me put down a visualize height field visualizer, and I'm going to remove the material and set default tinting, custom tinting, and I want to see the flow is the information I'm interested in. Obviously if we had a much higher resolution, we'd be getting a lot of awesome details. And then which one, the bedrock, and you can see there's a lot of cool details that we can use and maps that we can use to add details to our geometry. This is the height, mask, we don't have any masks, and the water. And this is really cool because we can use that to add actual water in the scene if we wanted to. Cool, I think that's pretty much it for the terrain tools and how to use it. The next video we're going to learn, I'm gonna show you a technique on how you can do tileable noise using the height field. Now that we took a look at how to create various deformers and to create various height field, we're going to look at one last thing, which is generating noise patterns that are tileable, and so far we've not done any of that. And I'm going to copy this node here, and I'm gonna dive inside and delete everything. I just copied it because I wanted the mapping, so I have that now. And let's see, let's connect the density. Now we saw earlier how we can create a linear map, an ST map, and the size of this grid here is 10 by 10. So we can do a vector to float of the x and fit range, of -5 and 5. Okay, and that would be our U axis, and this guy is going to be the Z axis, which is going to be the V axis. And all we have to do is we need to use that same technique that we did previously in week 2. And I'm going to connect the U here and the V, and I'm going to expose this map. And I'm gonna paste the map that we generated, which is, if you guys don't remember, let me show you the map. It's that torus UV. It's that torus rest position and warped in UV space. So this guy. Let's kill that. So now we have that information, and let's do a quick test. Let's export one channel, a vector to float, or actually, you know what? Let's generate a noise based on that. And it's a 3D noise. Increase the frequency. It's a 1D noise, and let's export it as a mask. And let's connect this. So mask, and actually it's doing something, so that's good. And right now the sampling is a little bit slow because we have a high res map, and it's doing the operation on how much voxels we have, can't remember. So the process is going to be a little bit slow to do the lookup on the textures. So that's why Houdini is freezing. Let's see, give it a couple more seconds. Hopefully it will come back. And the idea is to, instead of using the point position of the grid, we're going to use the information of the torus P position and use that to generate the noise. And this is exactly how we did the our textures, and we're going to do the same thing here. So let me could be that the map is too high. It's freezing. Yeah, I think the reason it's freezing is because the texture is EXR. So I'm going to save frame at as a RAT file, and I'll restart Houdini and come back. So I fixed the issue, and the problem seemed to be related to the EXR file. And what I've done is I made the 2K version of the image and saved it as a RAT file instead of an EXR. And this is the file I'm using now. Okay. So if I dive inside, we're sampling that torus, and we have a 0 to 1 UV coordinate by refitting the position. And now if we use that and generate a 1D noise, we can get the same textures. And the cool thing now, if everything I had planned for works, let's say 4, let's do how much, 5? 10. Okay, so 10, you can see it's perfectly repeating. Now there is an edge there which we have to probably expand 1 pixel and extend the image 1 pixel or crop 1 pixel. And let's see, it may be better if we convert this into a geo. So height field convert, and this should be, yeah, let's lower the density. I generated more points, so let's lower it 0.4. Okay, and let's copy that. Cool. So let's do another copy of this, and let's do 10 on the z-axis, on the z-axis. And now we should get a perfectly tileable terrain. So 9.99. Cool. And you can see now we have a perfectly tileable noise. Now let's go back and try something super quick. Let's do a Worley noise using this position, and let's subtract 1 minus 2, f2 minus f1. We have that, and let's increase the frequency, and maybe let's distort this position a bit using a noise that we generate using this. So I want to deform that point position itself, and maybe something like that. Okay, and let's multiply everything down a bit because I think it's too high right now. And let's take a look at what we have. Let's increase the resolution a bit. Something like that. Let's see what we get. Awesome. Now obviously the pattern are a little bit distorted, but overall it's very successful, I think, and we can easily tweak this and hopefully break all the edges. And I think with a complex geometry we should be able to do that. With a complex terrain we should be able to do that. In this video I want to talk about the assignment for this week, and what I'm mainly looking for is to see you guys create some maps that we can use in week 2. And every time you make a terrain that you can get some data out of it. For example, let's see, the one where we masked with the sphere, or pardon me, the one where we masked with the sphere, this is very cool to export this as a displacement and use it later, or you export it as a texture and add it later to drive the shader. And I want you guys to create about 4 or 5 different textures of these, and then with the tiling technique that I showed at the end, it would be cool to create 1 or 2 textures to use. We may not use it in this workshop, but I'd like to see that being created. And once you guys get comfortable with working with the terrain tools, the raw terrain tools, you can do whatever you want. You can do the bricks, you can do ground, you can do these things. The main thing, don't do terrains. Don't create an actual terrain with mountains and everything. I want to see small details that could be used in an environment to add details to a pillar or to a door or to a rock or something like that. I don't want to see terrain being used to create terrains. And once you get comfortable with using all the existing tools, saving maps out, and merging the channels into a single file and everything, then you can start looking at doing a little bit more complex processing using custom volume VOPS to create something a bit more complex. And this is definitely the next level. I'm not expecting all of you guys to master this in a week. This is definitely much more than a week. But if you guys get comfortable with the terrain tools and generate maps, that's all that is required. If you have time and you can afford to start looking into this, that would be really cool. And then the last part would be to use the terrain tools with the tileable texture and custom volume VOPS. What I don't want you guys to focus on is doing any rendering or any preview of the texture that we previously created. We're going to have plenty of time for each of those subjects, and I would prefer if you guys don't do any rendering and not even have to worry too much about saving texture. Just create them in Houdini, and then hopefully you guys will be able to create something really cool. Thanks everyone for watching, and see you next week. Bye bye.